And so I hope you all settle down because we are about to begin our webinar, no? So magandang hapon po sa ating lahat, no? Ayan. I think we are all ready na, no? Okay, so we have enough participants na sa ating webinar for today, sa ating Zoom webinar. Magandang hapon po. Okay, so I think we can begin na. So before we proceed, let us watch this video for the singing of the Philippine National Anthem. Okay. All right. Ayan. So maraming salamat UP Enquire no, for the music video ng ating Philippine National Anthem. To know more about UP Enquire, you may follow their social media accounts at UP Enquire. Ayan. So magandang hapon po sa ating lahat, no? Sa lahat ng nasa Zoom webinar, sa lahat ng nasa Facebook Live, hello, at sa iba pang social media platform, welcome po sa ating webinar entitled Manila Bay Conversation, Initial Findings and Assessment from the IM4ManilaBay Program. Ayan, magandang hapon po, no? Ayan, thank you po. Magandang hapon. I am Ses Abad. I will be your host for today. Of course, you can call me Ses, no? I'm one of the researchers ng Project Iwasto, a component project of the IM4ManilaBay program. And I am a civil engineer and also a graduate student, and I'm also a Gemini. So malapit na yung season namin. Now, anyway, enough about me. Sa mga hindi pa po familiar sa IM4ManilaBay program, Doc Ariel will give us an overview no, ng IM4ManilaBay later. Pero in short words, no, the program aims to characterize Manila Bay and its watershed and linked environment. No? So meron po tayong 4 na component projects which are Project Iwasto, Project Mapable, Charted Dream, and Project eSmart. No? So these programs will be reintroduced in a while. Ayan. So of course, we have to set ground rules during our webinar for today. So here are some of Zoom reminders no, para sa nasa Zoom meeting natin. Okay, next slide please. Ayan. So, for easier identification po, pagpasok po natin, maaari nyo pang baguhin ng inyong pangalan no, at pakilagay po ang inyong affiliation. Ano? So, halimbawa, Project Iwasto-SES or Mapable-AMI. Okay, so next slide please. Ayan, and during the event po, habang nagkakaroon po tayo ng talastasan, ng conversations with our project leaders about the updates, maaari nyo pong iwan ang inyong mga tanong sa ating Q&A na portion sa ating webinar dyan sa baba. Ayan. At sa lahat ng ating nasa Facebook Live, wag din po tayong mahihiyang magtanong dahil maaari po kayong magtanong at magbigay ng suggestions or comments sa ating comment section ng Facebook Live ng IM4ManilaBay program. Ayan. We will be reading that later po, those questions. Ayan. So ano pa ba? Meron pa ba tayong dagdag na reminders? Ayan. So certificates no only be given to Zoom participants. No? It will be emailed to you after you've completed the evaluation. Meron po tayong dagdag na quick reminder mamaya. Meron pa ba tayong reminder for that, guys? Wala na, no? Ayan. So of course, ayan. So para saan nga ba itong webinar na ito? So after the first year of implementation ng IM4ManilaBay program, of course, the mentioned projects na banggit ko nga kanina have accomplished some or most of their or our objectives, no? So basically in this webinar, the highlights and initial results from each project will be presented. The webinar again also aims to reintroduce the component projects of the IM4ManilaBay program. So today we are joined by our key stakeholders from different government organizations, no? Agencies, academe, and non-government organizations. No? So andyan po sina Secretary Fortunato de la Peña, Miss Alea from the ILG, Mayor Vico Soto, of course, at marami pang iba. Ayan. So I believe this will be a very fruitful day for everyone. So by the way, I know that online trainings and seminars, no, ay mahirap na in its natural form kasi hindi rin naman talaga tayo sanay dito, ano. Since maraming maaaring mawala ang connections or magkaroon ng unforeseen interruption, no. So I want all of our attendees, speakers, panelists, viewers to just relax and enjoy the day, no. So imagine this event like kapihan, no. Nag-uusap lang tayo and nag-share ng mga live updates at kung ano pa. Huwag rin po tayong mahihiyang magtanong mamaya sa Q&A, no? I am very sure that our speakers would love to hear all of your questions and suggestions. Ayan. So ayun lamang po, no? Again, kung meron po kayong katanungan, suggestions or comment, pakiiwan lamang po sa ating Zoom chat, sa Q&A portion or sa chat. At sa Facebook Live naman po sa ating comment section ng IM4ManilaBay program live. Ayan. So ayan, sige, tuloy lang po, no? Maraming nagchat-chat sa atin. Magandang hapon po, no? Maraming salamat po sa pag-spend ng inyong time, no? Sa pagpunta dito. So as you can see sa ating screen right now, ito po yung ating program flow, no? So magkakaroon po tayo ng mga messages mula sa ating key speakers, and of course, magkakaroon na po tayo ng presentations mula sa ating mga project leaders. At later, again, we will have time, no, para po sa ating Q&A, no. Actually, I believe that is one of the most important part of every webinar, no, yung Q&A, no. Okay, I know nami-miss nyo na rin yung mga event na merong live na kapihan, live na seminars, no, with free food, with free buffet, no. So sa atin walang gano'n, no, wala naman tayong pagkain dito, pero sana chill lang tayo, na mahirap talaga ang attention span, lalo na kapag online, no. So relax lang po tayo at enjoy the day. Ayan, so without further ado, I think we can formally start na, no? So to formally open the event, tinatawagan ko po ang aming program leader, Dr. Ariel C. Blanco, to give us an overview of the IM4ManilaBay program. Ayan, Dr. Ariel.
Magandang hapon po sa ating lahat. So I will share my screen. Muli magandang hapon sa ating lahat. Ito po ang ating IM4ManilaBay program or Integrated Mapping, Monitoring, Modeling, and Management System for Manila Bay and linked environments. Ito po ay funded by the Department of Science and Technology and also monitored and managed by the Philippine Council for Industry, Energy, and Emerging Technology Research and Development. Ang project po, ang IM4ManilaBay ay tutugon sa pagmamapa, pagmamonitor, pagsisimulate ng mga proseso na nangyayari sa ating Manila Bay at sa watershed. So nakita po natin dito ang mapang gawa ng eSmart na pinapakita na ang malaking bahagi ng watershed ay covered ng regions 3 and 4A. Ang framework po natin sa Mapable at iba pang proyektos ayon for Manila Bay, ay titignan po natin ang ridge-to-reef approach. Gusto po natin magkaroon ng magandang water quality sa kasalukuyang medyo degraded water quality. So kasama dito ang watershed modeling analysis, hydrodynamic and material transport modeling, at tinitignan po ang bahagi ng pag-aaral katulad ng solid waste, dredge materials at iba pa. Ito pong mga elemento ito ay kailangan i-characterize, kailangan magkaroon ng treatment. Sa case po ng dredge materials, pwedeng i-utilize or i-dispose. So nagkakaroon din po ng assessment of scenarios and evaluation of measures that can be used to improve the water quality eventually. Gaya po na nabanggit, meron po tayong 4 na component projects. Ang una po ay ang WASTO, ang Integrated Waste Analysis Survey Technological Options sa pangunguna ni Dr. Dan Chuling ng Civil Engineering, Institute of Civil Engineering. Ito po ay naglalayong magkaroon ng sustainable waste management sa pamamagitan ng waste utilization technologies at also yung policy support, community involvement. Nakita muna rin dito ang mga ginagawa nila sa waste characterization, pag-aaral ng mga waste management practices, gayon din ang environmental, social, economic, and technical considerations. Meron din po tayong proyektong tumutugon sa mga dredge materials. Ito po ang chartered dream or ang management of dredge materials, characterization, treatment, and disposal. Kung titignan po natin dito sa slide na ito, makita natin po merong collection of samples, characterization ng samples nito sa mga heavy metals, cyanide, sulfates, at iba pa, at ang treatment at utilization. Nilalayon po na magkaroon ng treatment sa mga dredge materials. Ito po ay mapakinabangan bilang kahalimbawa po ng sand. At ang project po naman na tumutugon sa pagmamapa at pagmamonitor gamit ang mga satellites at citizen science ay yung tinatawag nating Project Mapable. Ito po ay mula sa Training Center for Applied Geodesy and Photogrammetry. At ito ay ang development of integrated mapping, monitoring, and analytical network system for Manila Bay and linked environments or Mapable. Naglalayon po itong magkaroon ng pagmamapa at pagmamonitor ng water quality, hindi lamang po ng Manila Bay at Laguna Lake, kundi pati mga rivers, no? Kagaya ng Pasig River at Pampanga River. Nakita po natin dito ang mga parameters na nilalayong imapa ng proyektong ito. And last but not the least, we have Project eSmart, led by Dr. Herrera from the Institute of Civil Engineering. Ito po ang ecosystem modeling and material transport analysis for the rehabilitation of Manila Bay, o Project eSmart. Sila po ay nagsaset up ng mga models na tinatawag na hydrologic, hydrodynamic, at water quality models upang makita at mapag-aralan ng mga iba't ibang scenario at assessment. Kasama dito ang pagbabago ng land use and cover, kung paano ito nakaka-apekto sa kalidad ng tubig. Kasama din po ang mga basura at iba pang materials na pwedeng matransport sa iba't ibang bahagi ng Manila Bay. Aralin din po ang epekto ng mga reklamasyon at iba pang mga ginagawa katulad ng coastal protection. So IM4ManilaBay po ay nagpapasalamat sa mga partners at beneficiaries ng programa. Ando po ang Department of Environment and Natural Resources, PILG, mga LGUs, Philippine Coast Guard, Philippine Navy, MMDA at DPWH, and also PRCMO na bahagi rin ng DNR. So ganyan po, nakikipagtulong din po ang mga SUCs at HEI sa kasasakupan ng Manila Bay watershed upang magkaroon ng mas magandang pagmamonitor ng watershed. Yun po ang IM4ManilaBay. Maraming salamat at magandang hapon muli.
Ayan, so maraming salamat po ulit, no? Dr. Ariel, no, sa pagpapakilala po at pagpapresent again sa ating audience kung ano nga ba ang IM4ManilaBay program. True enough, no, ang programa po ng IM4ManilaBay ay hindi lang po nakukulong sa pag-aaral ng maaaring water flow, kung basura. Marami pong aspeto, maraming aspeto po ang IM4ManilaBay program. Kaya po kailangan talaga ng tulong ng maraming organizations, ng maraming agencies and all, no. So ayun. Again, so kung hindi niyo pa po napapollow, no, ang aming Facebook page, ayan po ang Facebook page ng IM4ManilaBay program. So I believe later, no, our session moderators will also post the link, no, ng Facebook pages ng different projects, no, para ma-update po tayo sa mga latest chika ng ating mga projects, So once again, maraming salamat po, Doc Ariel, no, for your introduction. Ayan. So next naman po, we will have series of messages na mula po sa different government agencies and stakeholders, no? So, pero bago po yun, sige, may pumapasok pa po sa Zoom. Muli po, maraming salamat, no? Nakikita ko, napakadami kung saang party po ng Pilipinas, no? So, PCG nandito po, from LG ng Baras Rizal, andito po, from May Kawayan, Norzagaray, at lahat pa po. No? Maraming salamat po sa pagpunta. Ayan. Okay, so punta na po tayo sa ating mga keynote speakers. No? So first, we'll hear a message from our beloved DOST Secretary, Secretary Fortunato de la Peña. No? So DOST Secretary Fortunato de la Peña is an alumnus of the UP College of Engineering. No? Before being appointed as DOST Secretary in 2016, Secretary de la Peña served the University of the Philippines in various capacities. No? As chairman of the Department of Industrial Engineering and Operation Research, no? As assistant to the executive director of the National Engineering Center, no? Or yung NEC natin, and as director of the Institute for Small Scale Industries, and as system vice president for planning and development, no? So as a faculty of the College of Engineering, so hello po, sir. He also taught industrial engineering and operation research for 43 years, no? So once again, let's welcome Secretary Fortunato T. de la Peña. Yan, Secretary, nandiyan na po ba?
Warmest greetings to everyone. The Department of Science and Technology welcomes you all in today's webinar as we explore innovative solutions to clean up and rehabilitate Manila Bay. Our heartfelt gratitude to the vibrant team of IM4ManilaBay for their generous invitation and allowing us to share quality time on this very pleasant and interesting discussion. Allow me to show a few slides regarding this particular project as part of my opening message. You are now about to see a few slides covering our project called IM4ManilaBay. It stands for Integrated Mapping, Monitoring, Modeling, and Management System for Manila Bay and linked environments. Okay, so there are 4 M's there. So that would be mapping, monitoring, modeling, and management systems. So the topic of my slide presentation is Manila Bay Conversations, Initial Findings and Assessment from the IM4ManilaBay program. Next slide, please. Manila Bay is one of the most important bodies of water in the Philippines because of its historical, cultural, and economic value. It is one of the country's major hub and international gateways due to its political, economic, and social center. But because of rapid population growth and urbanization, the water quality of Manila Bay has declined and the marine ecosystems have deteriorated. Next slide, please. It is important to protect our bodies of water as it is a source of livelihood, recreation, and water supply. According to the United Nations Development Program, over 3 billion people depend on marine and coastal biodiversity for their livelihoods. But today, we see 30% of the world's fish stocks overexploited, reaching below the level at which they can produce sustainable yields. Oceans also contribute as a carbon sink as it absorbs about 30% of the carbon dioxide produced by humans. And we are observing an increase of 26% in ocean acidification since the beginning of the Industrial Revolution. We also see an increase in marine pollution with an average of 13 pieces of plastic litter to be found on every square kilometer of ocean. In the recent expedition of Balik scientist Dr. Deo Onda into the Emden Deep, he saw the presence of marine litter in the third deepest part of the earth, a manifestation of how far marine pollution is reaching. Next slide, please. It is in this light that the Department of Science and Technology, or DOST, through the Philippine Council for Industry, Energy, and Emerging Technologies, R&D, or PCIEERD, supported the integrated mapping, monitoring, modeling, and management system for Manila Bay and linked environments, or IM4ManilaBay program, with funding in the amount of 65.9 million pesos and for a duration of 24 months. This one started on January 2020, particularly the first two projects. It aims to characterize Manila Bay and its watershed, as well as linked environments, to provide information for rehabilitation and management through water quality monitoring and mapping, hydrodynamic and hydrologic modeling, and dredge materials and solid waste management. Next slide, please. Today, we shall take a look at the initial results of the IM4ManilaBay project components, including ecosystem modeling and material transport analysis for the rehabilitation of Manila Bay, or eSmart, management of dredged materials, characterization, treatment, and disposal, also known as Charted DREAM, integrated waste analysis survey and technological options, or IWASTO, and the development of an integrated mapping, monitoring, and analytical network system for Manila Bay and linked environments, also called Mappable. So we have eSmart, we have Charted DREAM, we have IWASTO, and we have Mappable. Okay, so these are the four component projects of IM4ManilaBay program. Next slide, please. We are excited to hear the projects and accomplishments of these R&D projects so that we will know how we can maximize the multiple social, economic, and environmental benefits we can get from these projects. In the coming years, we will further strengthen our efforts to reduce environmental pollution and provide greater access to clean and safe water by generating environmentally sound, game-changing technologies and policies. We encourage our researchers, policymakers, key stakeholders, and the general public to support and implement these kinds of initiatives and projects which are aimed at achieving the sustainable development goals through an innovative and integrated set of solutions. Next slide, please. As the premier agency for scientific and technological activities and for formulating policies, programs, and projects geared towards national development, we at the Department of Science and Technology, or DOST, will relentlessly and continuously pursue R&D projects for the optimum benefit of all Filipinos and make science work for our people. We believe this is a good opportunity for all of us to deepen our collaboration and strengthen our scientific and technological research for economic growth and environmental sustainability. So this is IM4ManilaBay. Let us hear and learn more about it in this webinar. Thank you, and mabuhay kayong lahat.
Ayan, so once again, maraming salamat po, no, Secretary De La Peña, no. So true enough, again, marami po talagang factors, ano, ang nakakaapekto no, sa ating Manila Bay, no. At ang paglilinis ito, pag-rehabilitate will affect, no, definitely yung environmental sustainability and economic growth as well. Ayan. So maraming salamat po, Secretary De La Peña, no, for your continuous support para po sa science and technology and development sa Pilipinas. Ayan. So marami pong salamat. Okay? So ayan po no, ang dami na natin dito sa Zoom at sa Facebook no. Marami po galing sa Los Baños, Laguna. Hello po. From Pampanga, hello po. From Cabanatuan, from Antipolo, from EMB, Region 3, Nueva Ecija, no? Magandang hapon po. Welcome po tayo dito. No? At from San Jose del Monte City, kababayan, hello po. Magandang hapon. Ayan. So tuloy lang po. No? Tuloy lang po tayo. Okay, so next naman, we will also have a message from DILG MBCRPP, Miss Alea Carmela Arca. No? So Miss Alea Carmela Arca is the Assistant Program Manager of the DILG Manila Bay Cleanup, Rehabilitation, and Preservation Program. She took her undergraduate degree in UP Diliman with a course of Community Development. As an inspiring environmental planner, she is currently taking her master's degree in urban and regional planning, specializing in environmental management, and pursuing a research track related to institutionalizing strategic environmental assessment as a planning tool at the local level. No? So, ang hirap magitin ng word na yun, ha? So, maraming salamat to Ever Loving, one of my friends, Ever Pretty, Ever Gotesco, Miss Alea Arca. Ayan. Hi, Alea. Hello. Magandang hapon.
Hi, Sas. Good afternoon. Good afternoon then to all our participants of today's webinar. To Dr. Blanco, Secretary De La Peña, Sir, good afternoon. To Mayor Vico Soto, good afternoon po, and all our participants. No? So, first off po, the DILG through the Manila Bay Cleanup, Rehabilitation, and Preservation Program would like to express po our utmost appreciation to all who are taking their time po right now to learn more about the Manila Bay program. No? So, the efforts po of the national government agencies on the rehabilitation started as early as 2011, no? So it has been a decade, 2021 na po tayo ngayon. And now it's being brought up at the national level again to expedite the process, no? So some of you, no, may be thinking, no, why it took a decade to rehabilitate and even now ongoing pa rin po yung proseso ng ating rehabilitation. And when we compare it halimbawa po sa ating Boracay rehabilitation, to which at some perspective may be of similar undertaking, which also has taken less than a year or so. No? So siguro po to emphasize a little bit about the Manila Bay rehabilitation, in terms of intensity po and scale, Manila Bay composes of 187 LGUs, no, and more or less 5,700 barangays. No, so yung rehabilitation po na ito, hindi siya limited no sa ating coastlines. Definitely hindi din po limited sa coastlines along Rojas Boulevard, but expands to other coastlines of Bataan, Pampanga, Laguna, Cavite, and other than the coastlines, kasama rin po dito yung mga river systems natin, Pasig River being one of them, yung Obando River, and yung mga maliliit din ho nating mga esteros, no? So, yung intensity po in terms of scale ay napakalawak. Ganun din po, no, when you compare it to the Boracay rehabilitation, which I'm sure some of you are also familiar, yung intensity of effort po doon sa mga commercial establishments and others, no? Pwede ho natin yung i-times 187 dahil 187 ho tayo dito sa Manila Bay Watershed Area. And ang kaibahan din po nun ay iba-iba ho ang konteksto ng bawat LGU natin. Meron po tayo mga LGUs na highly urbanized, so iba rin ho yung approach to rehabilitation kapag po ganun. Mga LGUs na highly commercialized, LGUs po na tourism sites like Boracay, yung iba ho ay mga coastal LGUs. No? So yung complexity po of how this rehabilitation process is very much different po compared to the Boracay, pero same po that we are still protecting the environment. Pagdating naman ho sa economic perspective tsaka sa population, no, sa population ho natin, 38% ho ng population ng ating bansa resides po in these three regions, sa Region 3, 4A, and NCR. And in terms of contribution naman ho sa economy, a third of our GDP ay nanggagaling din ho dito sa tatlong regions na to. So you could imagine at the very least, po yung amount of economic activity, industrial activity, kahit yung mga human activities po that happen in these three regions on a daily basis. No, so what is clear po, as mentioned din po by Secretary De La Peña kanina, in the Manila Bay situation is how the environment has become negatively affected, no, dahil sa mga practices and developments dati sa mga regions na to that were mismanaged or could have been unregulated, no. So what we are dealing with right now is a decade or decades rather of neglect po sa ating environmental resources na kailangan ho nating habulin yon. Maliban doon, hindi naman ho tumigil ang ating pag-develop as regions, as a Manila Bay. So patuloy din ho yung mga economic development that we are kailangan din ho nating i-catch up on. Patuloy ang pagdagdag sa population, ang pagdagdag sa mga commercial establishment, and the list goes on. No, so ito pong rapid increase, no, sa ating mga population, halimbawa po yung mga possible na urban sprawl, ang effect po nito is kailangan ho nating mas i-regulate yung mga septic tanks ho na dapat ito ay nakakonect sa ating mga water concessionaires, sa ating mga local water districts. So very important ho dito yung provision ng ating sanitation services. Sa commercialization naman ho na factor, kailangan ho nating i-consider yung mga wastewater treatment facilities po nila to make sure po na prior po ito to being discharged sa ating water bodies ay treated po ito based sa class po, no, class SB po nung waters kung saan po sila magde-discharge. Ganun din po, no, ang atake kapag sa solid waste management. Kapag ho tumataas ang ating population, it could be assumed, no, na nag-i-increase din ang waste generation natin in the region. Hence, the call and the need po for better waste management systems, no. At the very least, alam naman ho natin ang waste management, it starts within ourselves, sa ating mga households, na dapat po ay we make an effort to reduce our waste, if not to segregate it, no, para po kapag kinolect na siya ng ating mga LGU and to the disposal po sa ating landfill ay hindi siya mixed waste. Pagdating naman ho sa ating mga kababayan na informal settlers, very much needed po ang shelter assistance, especially if titignan ho natin sa lente ng disaster risk reduction management, ay ito rin po, sila rin pong mga communities ang very prone and vulnerable po sa mga disasters, no, and sa mga hazards. We have flooding, may mga identified pong areas with liquefaction, storm surge sa coastal areas, no. So yung pagtingin po sa rehabilitation effort, it's very holistic na tinitignan ho natin yung economic side, tinitignan ho natin yung social side, institutional mechanism, infrastructure, and of course, most importantly, yung environmental sector. No, so ngayon po siguro, no, with these factors in consideration and before we listen sa mga results po ng mga research that have been conducted, gusto ko po kayong i-invite and mag-reflect po, no, ano po ba talaga yung essence when we say that we want to rehabilitate Manila Bay. Why do we want to do it? What is it for? And ano ho ba yung kailangan gawin para ho successfully siyang ma-rehabilitate? On the side of the DILG, and we hope po we share the same visions with the LGUs. To all our LGUs po present today, magandang hapon po, no? We see the rehabilitation process as an integral function po of the local government units that is consistent sa kanilang mga functions under environmental management, under local development planning, and of course, yung mga mandates po nila sa national laws and policies. Time and time again, no, lagi ho namin sinasabi sa LGUs na kahit naman ho wala tayong rehabilitation effort, ito po hong mga mandato na minomonitor po ng DILG under the Manila Bay Program are actually mandates of the LGUs for effective environmental management na kailangan pa rin ho nating i-comply and have to be acted upon if we really want to safeguard and protect our resources. No? So yung mga responsibilities po nito would be sa Clean Water Act po natin and sa Revised Sanitation Code. Pagdating po sa wastewater management, syempre sa solid waste management po, no, yung collection, efficient collection system and disposal of waste. Yung sa UDHA po, no, Urban Development and Housing Act po natin for shelter assistance, and sa DRRM Act naman po para po dun sa ating communities na residing in disaster-prone areas, no? So as these regions continue po to develop, dahil hindi ho natitigil, no? Ito ho ay reality, no? Sa ngayon po, center of development ho talaga itong 3 regions. The goal po right now is to put primacy po sa ating environmental to protection and to make the environment a partner po sa lahat ng mga aspeto ng development sa bawat sektor, no? Sa halip po na yung environment ang nagiging victim of development, we want environment to become a partner and be part po of the development in Manila Bay. No, so I can still remember, no, when IM4ManilaBay was launched. I think it was last June, no, kasi World Environment Day din yun, no. So a year po has passed. And ganun din ho sa sinabi ho namin a year ago, we welcome and we are very much appreciative of the research and initiative po being undertaken by this program. Kasi po, it has given us an opportunity to look into the rehabilitation in a different lens naman po, in a scientific perspective. No, so we also give ample importance po sa mga data na to and information, lalo na po sa national government, as we see and explore kung paano po natin ito maaaring magamit para masupport po yung ating national government to make evidence-based and well-informed decisions and policies po that will steer the direction of the rehabilitation effort. So, very much thankful po kami sa initiative na to. So we would like to congratulate the whole team for pulling this off, no, despite po the many challenges we had to face during the pandemic. And again, on behalf po of the DILG, I would like to thank the IM4ManilaBay program for this wonderful undertaking. And I am sure po, no, the results po of this research will be of great contribution, lalo na po in the succeeding years po of this Manila Bay battle. So again po, congratulations and thank you po.
Ayan, so maraming salamat, Miss Alea. Yun na po yung summary ng IM4ManilaBay conversation. Bira. Ayan, maraming salamat po, Miss Alea, no, sa inyong remarks. Very, very informative. No? Thank you so much po. Ayan, so marami pa pong pumapasok sa ating meeting, no? So meron from Bolinao, Pangasinan, tama po ba? Yeah. Masantos, Yangarem, magandang hapon po. Ayan. So andyan din sa ating Facebook Live si Dean Nelson. Hello po, magandang hapon po. Ayan. So tuloy lang po tayo, okay? So once again, thank you so much, Miss Alea Arcan. Okay. And of course, I am very happy to announce that we are joined today, despite his very busy schedule, by one of the youngest and one of the most loved mayor by the Filipino people, including me, syempre. Okay, so today we have with us Mayor Vico Soto. Ayan. So Mayor Vico Soto is the incumbent mayor of Pasig City, where he also once served as a city councilor. No? So Mayor Soto is actively involved in the city government of Pasig's various programs and activities for the continuous cleanup and rehabilitation of Pasig River and Manila Bay. No, excuse me po. He was also recently recognized as one of 12 global anti-corruption champions by the U.S. Department of State. Ayan. So once again, let us all welcome honorable and adorable Mayor Vico Soto. Ayan, Mayor, andyan na po ba kayo? Wait lang, Mayor, 5 seconds. I-screenshot ko lang po ito.
Magandang hapon, Ses. Salamat sa napakagandang introduction sa akin. Sobrang ganda ng introduction mo. Malamang mas mahaba pa yung introduction kaysa sa mensahe ko. Ano? Ikinagagala ko pong makasama kayo sa hapong ito, kahit na virtually lamang po. Ano? It's my honor and privilege to be here with you and to be a part of this webinar. Maiksing pagbati lang po sa akin, mula sa akin, sa ating mga kaibigan mula sa DOST, of course led by Secretary De La Peña, sa DNR, Secretary Simatu, sa ating mga kaibigan sa DILG, si Ma'am Alea. Narinig po natin yung kanyang mensahe at nagpapasalamat po ako, Ma'am Alea, no, kasi tuwing i-grade po kami ng regional task force, regional interagency committee, kinakabahan kami, baka bumaksak kami, ano, pero natutuwa naman kami dahil medyo tumaas ng konti yung grade namin to 90-point-something%. Ano, last year mga 89% lang, so kahit papaano tumaas. To everyone, sa mga kaibigan natin mula sa UP, sa iba't ibang lokal na pamahalaan, mga taga Senro, Menro, mga taga Akadim, of course kay Dr. Ariel Blanco, na nag-invite sa akin para makasama dito at magbigay ng mensahe. Maiksing mensahe lang po mula sa akin dahil alam naman natin ang pinakamahalagang bahagi ng webinar na ito ay yung presentasyon ng mga project lead natin, yung 4 na project lead po natin, and of course, yung question and answer portion natin. But before anything else, I also want to congratulate and thank everyone who has been involved with the IM4ManilaBay program. Napaka-importante po ng ginagawa ninyo. Minsan hindi kayo napapasalamatan or maybe not so much attention is given by the general public to this project, but it's definitely something that is very important moving forward. Tayo po bilang mga tao, human nature, minsan yung mga marami tayong problema na hindi natin napagtutuunan ng pansin. Kasi ang human nature, pag short term lagi yung gusto nating pinagtutuunan ng pansin. Pag medyo long term or hindi natin kaagad nakikita yung epekto, ay minsan hindi natin hindi natin tinitingnan. Halimbawa, pagdating sa sakuna o pag may baha, syempre pag nandyan na yung sakuna, pag nandyan na yung baha, very reactive tayo. At siyempre, tutugon tayo, gagawin natin kung ano yung pwede natin sa disaster risk management natin. Pero pag tapos na yung baha, pag tapos na yung sakuna, minsan nakakalimutan na natin ulit na meron tayong mga steps na kailangan gawin para makasiguro na hindi na yun mangyayari sa susunod pa. And we really need to employ new solutions, innovative solutions, just like what you're doing, employing the use of IT, technology, engineering solutions, and thinking long-term towards sustainable development. Gaya nga ng sabi ko, madalas reactive tayo at hindi nagiging proactive. Sakit po namin yan kahit sa mga LGU at sa birokrasya in general. Pero kailangan na ma-realize kayo po, karamihan po sa inyo, mga eksperto kayo sa mga field ninyo, pagdating sa environment, pagdating sa siyensya, kayo po mga experts. Pero kami po, mga ordinaryong mamamayan na hindi naman talaga masyadong maalam o hindi naman eksperto sa science, hindi naman eksperto pagdating sa environment, kailangan ma-realize din po namin na lahat ng mga problema natin, even when it comes to pandemics, nakatali po yung mga problema natin. Ibig ko pong sabihin, halimbawa may nabasa akong article nung isang araw, yung climate change, yung global warming, yan isang problema na minsan hindi natin napagtutuunan ng pansin o sinasabi natin ay may mga mas pressing tayong problema. Pero yun pala, kapag nagtuloy-tuloy itong climate change at nagtuloy-tuloy yung global warming at matutunaw yung mga ice caps natin, hindi lang sa tataas yung water level natin, kundi meron para doon mga ancient microbes sa Arctic ice caps na maaaring pagmulan ng panibagong pandemic. So yun po yung sinasabi natin that these problems are really interrelated. Yes, today we're facing a pandemic, but we can't also forgo the other problems, especially looking towards sustainable development and long-term solutions. Kami po sa lokal na pamahalaan, buong-buo po ang suporta namin sa IM4ManilaBay project program at lahat ng mga proyekto na nakasama dito. Sa amin po, siguro very quickly, dalawang important lessons in protecting our environment and pushing for sustainable development. Number one, we need the political will to implement existing laws. Isa pang sakit natin sa birokrasya, minsan gusto natin nagdadagdag tayo ng rules, regulations, pero yung mga existing na kailangan lang natin i-implement, nakakalimutan natin. At sayang naman yung pinaghihirapan ninyo, yung mga researchers natin, yung mga developers natin, yung mga nasa academe natin. Kung kami na nasa executive ay hindi natin may implement kung ano yung nasa findings, so hindi natin may execute ng maayos kung ano yung nasa batas na rin at kung ano yung nakikita at sinasabi ng mga eksperto. At pangalawa, we need to involve more stakeholders. We need to include and empower all stakeholders involved in order to come up with a better, more inclusive and long-term solutions. Let's increase the level of people's participation in everything that we do. And as we do that, makikita natin natataas din ang level of success natin sa implementasyon ng execution ng mga kailangan natin gawin to protect the Manila Bay, to improve the environmental situation in our waterways. Kung gusto natin na talagang yung mga maayos yung mga septic tanks natin, yung mga discharge of wastewater na hindi na diretso sa ilog, kailangan hindi lang yung pamahalaan mismo ang kumikilos, kundi ang bawat stakeholder mula sa academe hanggang sa mga scientists, hanggang sa business sector, hanggang sa ordinaryong mamamayan at sa lahat ng residente natin, kailangan na ikibahagi at kasama po sila. Hindi lang bilang nanonood o benepisyaryo sa mga ginagawa natin, kundi isama natin sila, empower natin. At pag nagawa po natin yung pagsasakapangyarihan ng ordinaryong mamamayan, kahit patungkol sa environment at environment protection, then we will be able to see the improvements slowly but surely in our region, in our country. Patuloy po ninyo, ipagpatuloy po ninyo ang lahat ng ginagawa ninyo. Kami po mula sa lokal na pamahalaan ay taus-pusong nagpapasalamat sa inyo, to everyone who is a part of the IM4ManilaBay program. Maraming salamat at congratulations po sa inyo. God bless at ingat po kayo parati.
Ayan, so maraming salamat po, Mayor. Thank you po. So maraming salamat po, Mayor Vico, Miss Alea, and Secretary De La Peña, no, para po sa inyong mga key messages. I think meron tayong certificate for our speakers, no? So presentation na po tayo ng certificates, okay? So what do we have here? Ayan, so certificate of appreciation is, this award is presented to Secretary Fortunato T. De La Peña, Miss Alea, of course, Arca, and Mayor Vico Soto, no, for being part of our panel of speakers during the Manila Bay okay. Conversations, initial findings, and assessment from the IM4ManilaBay program, organized by the UP Training Center for Applied Geodesy and Photogrammetry, Institute of Civil Engineering, and DOST Industrial Technology Development Institute, held on 16 of April 2021, 1:30 to 5 p.m. Ayan, signed by our program leader, Dr. Ariel C. Blanco. So once again, maraming salamat po, Secretary De La Peña, Miss Alea Arca, and of course, Mayor Vico. Thank you so much po for spending your time to us. Ayan po, no, with us. Ayan. So pwede po ba tayong mag-picture? Ay, wala na ata si Mayor, busy na. Okay, so tayo na lang, Miss Alea. Ayan, so, okay. All right, smile, hold that beautiful smile. Ayun pala si Mayor. Hello po. Alaya, alis ka muna. Charot. Joke lang. Ayan na po. Okay, up. 1, 2, 3 po. 1, 2, 3, smile. Ayan. Thank you so much po. Maraming salamat po. And enjoy the rest of the day. Bye po. Thank you so much. Ito ko nagbabay. Anyway, so maraming salamat po muli, no? Wala na akong masabi. Starstruck ako. So ayan. So thank you so much po, no, sa inyong time po, no, and effort, of course, to support the IM4ManilaBay program. Ayan. Thank you so much. Okay, so bago tayo dumako, so guys, eto na, no, malapit tayo sa main event. Ang haba kasi ng araw natin, no. Ayan, so bago po tayo dumako sa ating main session for today, no, so magkakaroon lang po tayo ng very short na icebreaker. Ayan, so panelist, sa ating po mga moderator, ano nga bang ating first icebreaker for today? Ayan, so ang una po nating game is The Price is Right. Ayan, so hulaan nyo lamang po ang presyo ng product na ipepresent namin. Okay? And then, kailangan po yung sagot nyo is within the range ng correct price. So halimbawa, meron po ako ditong muesli, nakikita nyo po ba guys? Kayo na po mag-adjust, ako lahat. Ayan. So halimbawa, ang presyo nito ay 30 pesos. Okay? Tapos sinabi namin na ang price range must be plus minus 5. So ibig sabihin, kailangan ang hula niyo na presyo ay from 25 to 35, no? Galing ko sa math. So from 25 to 30, bahala na po kayo ma-plus, kayo na po mag-adjust. Ayan. So paki-comment lang po sa ating chat ang inyong mga sagot sa ating questions, no? At sa ating Facebook Live. Ayan. So, okay, so ano ba yung ating first product, Melvin? Ayan. So, magkano po ba ang presyo ng Echeverria Helena? So, sino po makakahula? So halimbawa po ang totoong presyo nito ay 100 pesos. So kailangan ng sagot na ay 80 plus, ang hirap ng math, 80 to 120. Ang galing. Kasi in English ako dati, alam ko yan. Ayan. Ano pong premyo? Wala, ang premyo po ay, may premyo ba tayo guys? Trip to Jerusalem. Pero sa Christmas party na po. Ayan, so meron kayong 5 seconds to think. Ayan po. Yung una pong makakatama ng sagot, yun po yung mananalo at makakatanggap po ng 5,000 pesos. At yun po ay manggagaling sa huling makakatama ng sagot. Okay lang po ba yun sa inyo? Ay, ang dami ng chat. Ayan, so, okay, magkano ba ito? Next slide, please. Magkano ito ang Echeverria Helena sa mga plantit? 788 pesos po. No? Mamaya po isa-share namin kung saan ang galing yan. So, meron man nakahula, guys, ng tamang sagot. 768 to 808. Dapat yung sagot. Ma'am, Sir Robin, late na po. Sir Maduas. Sige, ako na lang mag-check. Ako lahat. Host na maintenance pa yan. So wala po bang nakatama ng sagot? Sa ating Facebook, yung mga comment kasi sa Facebook natin is, hello po, I'm from my house. Ay, hello po sa house, no? Ayan, so wala po nakahula ng tamang sagot, no? Mahal po kasi yung mga plants ngayon. Hindi ko alam kung bakit. Nung nagka-pandemic, nagmahal yung mga plants. I don't know why. Anyway, so next slide please. Ano yung ating next product? Ayan, so air fryer Hanabishi H8. Mababasa na naman yan. So yung presyo po natin ay plus and minus 150 pesos. Okay? So sige, you have 30 seconds. So laban na ng mga LGU. So tignan po natin. 4-5. Mahal po ang air fryer ng to, no? Ito po ay hindi paid ad ha. Wala po ito. Random ano lang po yan. Random product. 3,000. So magkano? Okay. 1,500. 5,950. Okay. 1, 2, 3, 4.56. Oh, wow, thank you po sa inyong effort. Okay, so magkano ba ito? Ano? Guys, magkano ang ating air fryer based sa ating research? At 3,450 po. So, 3,450. So, dapat po ang sagot na ay 3,3236. Ang galing ko sa math. So, 3,4... ay, hindi. 3,450. Ay, bawal po. Wala po naka... Oh my God. Tama po si Miss Mikay at up.edu.ph. Ayan. Congratulations po. Mananalo rin po kayo ng air fryer, no? Ayan. Pero ano lang po, tawag... Biro lang po, baka magbayad ako. Wala po, biro lang po. Ang mapapanalunan niyo po ay mga dredge materials mula sa Charted Dream. Pwede po ba? So next slide please. Ayan, so magkano ba ang COVID-19 swab test? No, ito po ay galing sa Red Cross. 2K, 1.5. Okay. So sa ating Facebook, magkano ang comment ng mga tao? Natabon na tuloy yung mga Q&A. Sorry guys. Sorry po. Okay. 3. Uy, ang mura naman. Bakit may comment ng 50? Pero pwede naman kung may PhilHealth. Alam ko, subsidize. Hindi ko sure pala. Sorry. Ayan. So, magkano ba ang presyo, Melvin, ng ating COVID-19 swab test? Before tax or after tax? Okay. Next slide, please. Ay, ayun na pala. Hindi nagbabasa si girl. 3,800 po, no? So, dapat ang sagot nyo ay 3,600 to 4,000. Ayan. So, ay, ang galing naman po ni from MBCO, hindi na po mabasa ang kanap. MBCO SMO Laguna. Ayan, congratulations po. Okay po. Mananalo po kayo ng ng free testing, no? Pero mic testing po mamaya sa ating Zoom. Sarap. Ayan. So next product po natin. So ako ulit magna-next. Ay, wala na pala, wala na po. Marami po kasi yan, kaso mas mahalaga yung main event. So tinanggal na po namin. So yan po yung aming mga references, Hanabishi, Plants Manila, Instagram, Lazada, Watson, and all. So ayan, maraming salamat po. Okay, so pag may time pa po later, no, magsasagot pa po tayo. Ayan, so ready na ba? So nagising yung ating mga audience. Okay. I am glad to join this webinar. Appreciate the organizer for putting up this event all together. And the beautiful host. Thank you so much po, but I know it already. So, ayan. So again, ready na po ba tayo? Ayan. Pasensya na po, no? Wala po talaga tayong pa-buffet. Alam ko, nami-miss nyo na po yan sa mga seminars. Ang libreng buffet natin. Alright. Although, syempre, yung mismong interaction with other people, no? Yung pinakamahalaga during the event. Anyway, we'll all get through this. Okay, so ayan. So I hope andyan pa po tayong lahat, no? To formally begin the main session. Okay. Wala pala ata sa Zoom, wala po kasi sa Zoom webinar setup ng mga ng mga emoticons, mga reactions, no. So hindi po tayo makakapag-clap ng hands. Okay. Anyway, so naglalag ata ako. Alright, so kung ready na po tayo, we will formally begin the main event po ng ating wait lang po, technical difficulties. Wait lang po, 5 seconds. Diba? Bayad pa lang ating airtime. Okay, so ready na ba? Okay, so to formally start our event po, tinatawagan ko po ang ating first speaker for today. From Project eSmart po, Dr. Eugene C. Herrera. Ayan. So Dr. Eugene C. Herrera is an associate professor of the Institute of Civil Engineering, UP Diliman. So professor po namin siya, naging prof ko rin po siya. He obtained his BSCE and MSCE from UP Diliman and his Doctor of Engineering degree from Tokyo Institute of Technology in Japan, with major in environmental informatics of water resource systems and specialization in hydrodynamics, ecology, and limnology. He has been involved in various research and engineering design projects with the National Hydraulic Research Center on Flood and Sediment Management, Decision Support System Analysis, Water Availability Studies, Environmental Assessment, and many other utilizing physical and mathematical modeling methods. He is also the local project counterpart on environmental systems modeling of the JICA-funded Blue Cares project. Currently, he heads the ecosystem modeling and material transport analysis for the rehabilitation of Manila Bay, or the project eSmart, Again, a DOST-PCIEERD funded project under the IM4ManilaBay program. Once again, let us all welcome Dr. Eugene C. Herrera. Ayan, Doc Eugene, okay na po ba? All right, so the floor is yours na.
Okay. Maraming salamat sa lahat ng dumalo. Thank you, sis, for that introduction. So now, I will share my slides to show to you the results and output of Project eSmart after 1 year of implementation. Can you see my slides? Okay. Okay, the where, the how, and the when of Manila-based hydrodynamics. So for any rehabilitation effort or management of any water body, it's important for us to answer the question where. So where is the source of the problem? Or where do we start in rehabilitation of that specific area? Or maybe we want to answer how. How can we arrive at a solution? How do these problems originate? Or maybe we want to answer when. When is the right time for us to rehabilitate? Or maybe when do we target the cleaning efforts so that the efforts will all become effective. And so here I present to you the initial findings and assessment for Project eSmart. Okay, to go through the presentation outline, I will quickly go through the objectives and methodologies of the project, and then go straight to the output, meaning what had been discovered or what are the results based on the studies done by the project, and then come up with scenario analysis for us to better appreciate the results of Project eSmart. So for any solution intervention that we want to implement in a water resource system, such as that of the Manila Bay, we always need to look at the bigger picture. Okay, we cannot just target Manila Bay as is. So we need to determine what water bodies interact with the bay, what link ecosystems are also contributing to the state or status of Manila Bay. And for us to be able to do that, we need to determine how these systems are interrelated. The watersheds, the link ecosystems such as that of the Pasig River and Laguna Lake, and that of the entire watershed. Okay, and so for us to be able to come up, no, para maka-arrive po tayo, no, sa better understanding ng ating target area, which is Manila Bay for this case, we need to make use of models or numerical models for understanding the system better. So the key to any rehabilitation effort is really understanding the system, no? So that we know how to target, when to target, no? And what to target, no? In the solution interventions. And so the primary objective of this project, no, is to streamline solution interventions, no, with the use of numerical modeling analysis of the integrated Manila Bay, Pasig River, and the Laguna Lake and surrounding watershed system. And considering, no, the pandemic and the limitation, no, for data gathering or primary data gathering, no, we are very much, no, appreciative, no, of the contribution of the different agencies, no, in sharing to us, no, the secondary data that form the baseline, no, information, no, for us to generate the models, no, that we are using now. No. Specifically, the digital elevation models, no, the land covers, and then the rainfall data, discharge data, no, and different hydrometeor information, and that came from different government agencies and linked institutions. So maraming salamat po for that. No? Because of that, we were able to set up, no, our models, no, well represented, no, by the physics, no, of the study area. Okay, and so we were able to come up with and set up our hydrologic model. So hydrologic model po, no, this is that representation of how much water, no, is transported from the watershed ng ating study area, which is Manila Bay. And for us to be able to, no, consider the entire, no, area, no, this large area here of the watershed, no, we need to use models, no, for us to quantify how much is discharged into Manila Bay, for example. And for us to be able to do that, no, we set up models, no, describing this entire large watershed, no, which is roughly around 17,000 square kilometers of area. Okay, so utilizing digital, no, elevation information, land covers, soil representing the area, study area, and then rainfall information on historical and short term. And then with discharge information, no, for example, no, you're able to calibrate and validate the models, no, and come up with representative discharges, no, from the entire watershed of Manila Bay. Okay, and for us to be able to make sure that our models are robust and are able to replicate on the actual conditions of the hydrology of the Manila Bay watershed, no, we needed, no, to calibrate. No? So calibrate po, no, ang proseso where we adjust, no, hydrologic parameters, no, so that the models, no, will be able to replicate, no, yung actual discharge data or information. And we did that, no, for several basins, no, depending on the available or the availability of the discharge information. Okay, and so, no, based on the hydrologic modeling, no, we were able to quantify historical, no, values of river discharges. These are continuous river daily discharges, no, since the 1970s until the present time. Now we have river discharge information for all the rivers that are discharging to the integrated Manila Bay, Pasig River, and Laguna Lake system. So you can see here that among, no, the basins that contribute the most in freshwater input to Manila Bay, Pampanga, no, is the largest at around 5,260, no, cubic meters per second, and that's a total annual. And then followed by the Laguna Divide Basin, no, of around 1,250 cubic meters. So those two large watersheds contribute the most, no, to the freshwater influx of Manila Bay. And then correspondingly, we move on now, no, to the hydrodynamic model. So this is the part where we model the open water, no, conditions of the integrated Manila Bay, Pasig River, and Laguna Lake. Something like this one. So we want to know, no, how water moves, no, within this integrated system. And for us to be able to capture, no, such dynamic exchange of waters, no, between these two large bodies, we needed to set up a model that is integrated, as you can see in this figure. And correspondingly, we inputted all the hydrologic output of these river discharges around Manila Bay together with that of Laguna de Bay. And so we were able to come up with a hydrodynamic model that is representative of the actual conditions as that can be observed on the field. So something like this, we calibrate in terms of water level for now, at least for Manila, Laguna de Bay. And this one, so you can also see the comparison with the tidal conditions of Manila Bay, where we were able to come up with relatively good models already. So that we can say that later, if you want to utilize these models for scenario analysis, we can say that we can now foresee how the integrated Manila Bay, Pasig River, and Laguna Lake system would respond to different management interventions. Okay, so this one basically shows you the dry season conditions simulated between May 20 to June 3, between the near surface and the near bottom conditions. I will now focus more on the discussion on the dynamics of Manila Bay. So you can see here that during this time, much of the water movement is counterclockwise because of the prevailing wind, which is southeast during this period, at least for the near surface. For the near bottom, it's really more of because of the tidal signal, in and out, depending on the high tide and the low tide, or the flooding and the ebbing conditions. And then moving forward, these are just snapshots for different tide conditions. So I will describe here. Spring tide is the time when the difference between the range of the low tide and the high tide are highest within the month. And flood tide is the condition, tidal condition from low tide going to high tide. So much of the waters can be expected to flow in to the bay. As you can see here, the near bottom and the near surface current conditions are flowing into the bay. And because this is during a flood tide condition, and it happens during a spring tide condition. And then for the ebb tide condition, on the other hand, ebbing is the condition from high tide going to low tide. So much of the tidal waters are moving out of the bay. As you can see here, for the near surface and the near bottom, there's a difference in flow dynamics, which is very representative of the estuarine flow condition. Pag sinabi po natin estuarine flow condition, there's a separation between the near surface and the near bottom flow dynamics. As you can see here, the near bottom is sluggish, but moving inside the bay, but the near surface is ebbing and moving out of the bay with a counterclockwise flow direction. Okay, and then we move on to the neap tide conditions during the dry season. So neap tide po, this one is the lowest tidal range within the month. Okay, and so you can, or within the tidal cycle. So you can see here that during the flood tide, near surface waters are moving upstream, okay, but at a much lower current velocity as compared during the spring tide conditions, and the near bottom is also moving inside. Then during the ebb tide conditions, moving out naman, out of the bay, okay, and then the near bottom is still moving in, but at a more sluggish or slow velocity distribution. So as we can see here, paiba-iba po on how the current or the water is moving within the bay, depending on the timing within the month, okay, and the prevailing wind conditions. And it just emphasizes that Manila Bay hydrodynamics is mainly defined by, number one, river discharges coming from its watershed. Number two, the tides that are coming from offshore. And number three, the wind conditions that are pressing or stressing on the surface of the water body. Okay, and then these are the conditions naman pagdating po ng wet season. So mas intense po to because we can expect that there is more fresh water coming from the watershed of the bay. And so the difference between the fresh water and the salt water will tend to induce yung tinatawag po natin density-induced currents. Okay, as we can see from this animation, you can see again, there's a difference between the near surface and the near bottom conditions. So moving forward again with the snapshots, the spring tide condition, flood tide. During this time, when the wet season arrives, the prevailing wind is more southwest. And so we can expect that the wind is affecting yung flow condition. So kanina, it's counterclockwise. Now we can expect a clockwise gyre circulation of the near surface current during the wet season. The near bottom is coming in as the saltwater flux is much heavier and is coming into the bay during a flood tide condition. Moving forward, during ebb tide, ito po yung time where much of the waters are flushed out with the aid of the river discharges. These are more intense now. Moving out tide and the freshwater flows are moving out of the bay. So you can see that the fresh water po that's coming from the watershed is mainly near the surface. Samantalang near the bottom, it's mainly incoming flows from the offshore salt water or seawater. Okay, these are conditions during mid tide. So these are during the times when the tidal range are shortest. We can expect much lower flow velocities, but the gyre circulation, which is clockwise, is maintained again near the surface because of the prevailing southwest monsoon condition. And then the near bottom is flushing in from towards the bay head. Offshore waters coming in at the near bottom conditions. And then this is the condition during mid tide. Again, ebb tide conditions, palabas ng tubig. And so the gyre is still there, but much more weaker, and then sluggish bottom conditions. Okay, so if we try to remove now the effect of tides, which is mainly tries to affect yung water movement because of yung labas-masok ng tubig coming from offshore, a good way to see this is using residual current analysis. So this is the part where we remove tide, or we average the tide conditions and see how wind and river discharge flux affect the circulation patterns. So these are the conditions during the dry season. As you can see here, the wind conditions are from the southeast, and then the gyre circulation remains to be counterclockwise with this general flow circulation. And then the bottom currents are moving in towards the bay. So these are more important for assessing yung tinatawag nating material transport. Yung, if we want to know or we want to learn how any particular material will be transported or gumalaw within the bay, kailangan po natin tignan yung tinatawag nating residual current. Ito po yung mas long-term yung effect because the tides are just coming in, going out, and it repeats within the day, within a month, and so on. But this one is much more for the long term. Okay, and then these are the conditions during the wet season. So you can see the gyre circulation is now clockwise, again because of the southwest monsoon, but the bottom current remains to be towards the bay. Okay. Also, because of the integrated model that we have set up, na-capture po natin yung pasok labas ng salt water into Manila, to Laguna de Bay, which is a good validation of the water quality feature of our model, which shows that it satisfies yung observed, where in 2018 there is salinity intrusion that happened. Take note that salinity intrusion is not a yearly thing for Laguna Lake. It depends on the hydrology of Laguna de Bay. So if Laguna Lake has little rainfall during the year, so we can expect much salt water to flush in or to intrude. But if it has enough precipitation within the year, and then lake levels are high enough not to let or intrude, let the salt water from Manila Bay to intrude. So our model was also able to capture this dynamic condition or interaction between Laguna de Bay and Manila Bay. And so now with the models that we have, we can go on explore different environmental scenarios. Yung mga tinatawag po natin what if or what ifs condition. Because we have a model, if you want to explore any management intervention or maybe any conservation scenario, no, we now can make use of these models, no, and see how the system will first respond, no, before we do any actual, no, action, no, in the field, no, or bago tayo gumastos, no, for this intervention. And then we get to have a better understanding of the hydrodynamics, no, of the integrated system. So for example, if you want to see, for example, no, yung changing land cover's impact on the hydrology of Manila Bay watershed. So we have observed, no, based on the data, no, that we were able to gather from NRIA, that through the years, since 1988 until the present, we have changing land covers, no, within the watershed of Manila Bay, as specified, no, in detail by these ones. No. So, kitang-kita lang dito, no, is yung red one, no, urban area, no, has increased, no, from 1988 until 2015. So others, no, also increased vegetation and so on. So it depends on the location. Some urban areas, no, extended or expanded. Some rural areas, no, even became more vegetated. Okay, so with these changes in land cover conditions, will there be an effect or impact on the hydrology or expected discharges from these basins? No? As can be seen by the result, no, of our analysis, it depends on the location. So some areas have increased discharges. So ang assumption po dito is if we use the same land cover for the same rainfall event within a year, how will the changes in river discharges, no, become? So depending on the watershed, no, you have portions which increase, some decrease. No? So what is observable here is that for the Laguna de Bay Basin, for example, no, which is much more urban, no, as compared to the other watersheds, no, it has a significant increase, no, in surface runoff. No? So now much of the water is being transported on the surface of the landscapes, no, rather than or before even, no, going, no, downwards, no, towards the groundwater. So this can be seen further or in more detail here, no, where depending on the basin, a comparison between the 1988 and 2015 condition shows that for Pampanga River Basin, no, there's a decrease in surface runoff, but for Laguna de Bay Basin, there is a corresponding increase. Again, that has something to do with the landscape. No? And this is quite important, no, to present, no, mainly because if you want to manage, no, even those areas, no, far within the watershed of Manila Bay has a corresponding impact, no, to the Manila Bay environment, mainly because it will affect, no, the corresponding hydrology and the discharges, no, that can be expected to drain towards Manila Bay. So even if we are as far as in Pampanga, so we will have, no, an effect or impact on the management of Manila Bay. So moving forward, no, just to emphasize on the impact of the discharges, no, to Manila Bay, and what if ayun late tayo, no? What if walang river discharges, no, to Manila Bay? How will it show na there is a difference in the circulation patterns within the bay? As we can see, no, in the residual current analysis, no, during the dry season, this is the condition if we have the regular discharges towards river discharges toward Manila Bay, and this is the case where we don't have any freshwater discharge. So there's a significant effect, no? Even if you have your winds here, okay? So you can see that for a wind discharge, you can see the gyre circulation to be present, as we had seen earlier, but if we don't have the freshwater discharge, or if the freshwater discharge are changed, no, you can expect, no, such a change in the flow conditions of the bay. So we can see how important, no, the river discharges are in the simulation of the hydrodynamics of Manila Bay. So you can see the conditions here, okay? Dry season conditions, no? Similarly, no, we'll have corresponding differences. The wet season conditions, near surface, okay? So a significant difference between the two conditions. And then this one, near bottom, you can see how much, no, is the change in circulation pattern near the bottom between a with freshwater discharge in Manila Bay and without a freshwater discharge. Okay, And then, laruin pa natin yung model, no? What if we have an oil spill scenario, no? In Pasig River, no? So sabihin natin sa may Santa Ana Ferry Station. And so we can play around the model, no? Since it's now robust and it's representing the system, let's see how different will the oil slick move or distribute within the bay if the slick is or the oil spill happens at different times of the year. So this is the condition during the dry season. As you can see here, much of the slick are distributed both at the north western shore and at the southeastern shore, distributed all over the bay. But during the wet season, much of the slick is concentrated on the Cavite shoreline. So it did not even reach the Pampanga Bay. So for any cleanup operation, may it be oil slick or oil spill or probably any pollutant, depending on the time, we can actually target where to focus first for an effective cleanup operation. Okay, these are just snapshots just to emphasize on the difference in the distribution of the oil spill depending on the time of release of the spill. So 10 days, 40 days, and 80 days condition. So what if we have now a pollutant, and then we get to instead model oil, we model a particle that is representative of a pollutant. And so this one shows you a 1 year Pasig River pollutant release towards Manila Bay. So as you can see here, it almost takes like around 9 months before all the materials are removed out of the bay, which is almost gives us an idea of the hydraulic residence time of the bay. So to look further, during the 1 year release, these are the conditions at 0.5, 1.5 months, and so on and so forth, roughly around 10 months. And then this is the difference between two different releases, one in the dry season and one in the wet season. So similar to the oil slick, or the oil slick is much lower, but this one, much of the concentration were found in Pampanga Bay during the dry season, while during the wet season, they are much more concentrated along Bacoor Bay and along Cavite shoreline. These are just snapshots describing the difference between the dry season and the wet season. And then we can again simulate something like what are the expected impacts of the planned coastal developments in Manila Bay. Of course, modeling will have their limitation, but at least with such representation, we can already have an idea of the possible impacts of such coastal developments. So another what if here is that there are a lot of reclamation projects that have been proposed, and some are already accepted. Okay, and so what if all of these proposed later on will be there in Manila Bay? What will it have an effect on the circulation patterns of Manila Bay? So we can do a with and without scenario. So this one shows you the simulation between a with reclamation and a without reclamation scenario, where we can already see that the waters here are stagnated because of the presence of the reclamation area. And so at the confluence, the restricted channels formed because of these large developments, we can expect changes in the water movement. Okay, so these are just snapshots comparing the without and the with reclamation scenario. I think we can look into more detail here where specific locations there's a significant increase in current. Okay, so take note, these currents are depth average current. So we can see that there's an increase when there is already an obstruction because of the reclamation. So take note that these are normal conditions. We can expect that these velocities will even become faster if there is a storm event or a typhoon condition. So this only shows us at different locations, the with reclamation, the blue line here shows faster moving current as compared to the red line which shows a slower moving current. for a with and without reclamation scenario. Okay? So you can see here further, no? In Cavite, during the wet season, there is a weaker velocity because again of the effect of the presence of the reclamation areas here, no? Added into the model. Okay, and lastly, no, we were also able to come up, no, with a hydraulic model, no, of the coastal area in Bulacan. So this is a flooding condition analysis na during, you all know this, na September 26, so this is Typhoon Ondoy. So this is just an animation of the maximum flood depth, no, that is expected in the Bulacan River Basin, which is in coastal Manila Bay also. You know that there is an ongoing large coastal development in that area. So if we just, this is the case where there are no obstructions, no, near the coastline or no developments. So this is how the flood envelopes in the river basin for a no development condition. So this one shows us if there is a large development in this area, for example, so we can expect the difference in flood depth for a with and without flood condition, which says that this yellow or light green area here, no, is an increase in flood depth because of an expected development in this locality, which is around half-meter depth of flood depth. So that is on the condition that, of course, no flood control or no drainage systems that are effective enough will be placed to remove the possible effect of these added flooding conditions. And so I summarize our 1 year of project output, where we were finally able to come up with a robust hydrodynamic model for year 1, because we are projecting at a water quality model for year 2 that is able to describe the basic characteristics of the system within acceptable accuracy. So it was also shown that the Manila Bay hydrodynamics is governed by tides, freshwater discharges, and atmospheric forcing due to wind. Okay, and there is significant exchange with the outer sea, the West Philippine Sea. So this corresponds to important implications to the hydraulic, residence characteristics, and material transport features of Manila Bay. And so with the calibrated and validated model that we have now, scenario analysis can now be performed for supporting resource use and conservation management decision making. So we can play around with the model and have a better feel of how Manila Bay responds to different forcing mechanisms. So may it be something good or may it be something bad. So better understanding would mean better management of the Manila Bay environment. Okay, I think that ends my presentation. Thank you.
Ayan, so once again po, maraming salamat Doc Eugene for presenting ang inyong pong project, ang ating project po and discussing about material transport analysis and of course ecosystem and by ecosystem modeling. So maraming salamat po Doc Eugene. Naalala ko na naman ng undergrad days. Ayan, sobrang informative, Ayan, sobrang dami pong tanong. Wag po tayo maiyang magtanong, Ayan, padagdag po ng padagdag. Mamaya po, we will answer those questions, Ayan, so ako po ay part ng Project Iwas to, and of course, I heard the other projects, pero ngayon ko lang formally na nakapag-focus, sa project ng Doc Eugene at sobrang informative, Grabe. Anyway, watershed discharge pa lang, sobrang dami ng data na pwedeng makuha for future studies. Anyway, maraming salamat po Doc Eugene. Thank you so much po for your time, Okay, so next naman po, to continue the event, let us welcome po the project leader of Charted Dream, Dr. Denvert C. Pangayao. Ayan. So Dr. Pangayao is a graduate of Bachelor of Science in Chemical Engineering at Pamantasan ng Lungsod ng Manila and Master of Engineering major in Environmental Engineering and Management and Doctor of Philosophy in Chemical Engineering at De La Salle University. No? He was a visiting researcher at the Université Paris, Est in Paris, ang hirap bagitin niya, France, and Tokyo Institute of Technology in Tokyo, Japan. No? So his field of specializations are chemical and hazardous waste management, green materials, no? Biochemical engineering, and biotechnology. Currently, Dr. Pangayaw is a supervising science research specialist and head of the waste management section under the Environment and Biotechnology Division of Industrial Technology Development Institute of Department of Science and Technology, or DOST-ITDI. No? So before joining ITDI DOST, Dr. Pangayaw is an assistant professor under the Chemical Engineering Department, College of Engineering and Technology of Pamantasan ng Lungsod ng Manila for 10 years and held numerous administrative positions. No? So once again, let's welcome Dr. Pangayaw. Andiyan na si Sir. Hi, Sir. Hello po. Magandang hapon. Okay, Sir, the floor is yours na.
Good afternoon, everyone. Okay. So I'm here to present to you our initial findings for Chartered Dream, the characterization of Tulihan-Tinajeros River sediment. Next slide, please. So first, let me introduce to you what is Chartered Dream. So Chartered Dream is the management of dredge material, wherein the characterization, treatment, and disposal of this material. This is one of the approved projects for the rehabilitation of Manila Bay. Our main objective is to provide technology for the management and utilization of this waste material into a new technology or new product. The project will be collecting dredge sample along the Tulihan-Tinajeros River system, and this dredge material will be used or will be placed to a physical and chemical characterization, after which this dredge material will be utilized into a construction material through a immobilization technique. Our project also aims to be beneficial to the community through technology transfer if this construction material will be favorable. Next slide. So where will we get our dredge material? So we'll be getting our dredge material into the Tulihan-Tinajeros River system, or what we call the Tuti River system. This encompasses many cities in Metro Manila, such as Caloocan, Valenzuela, Malabon, Navotas, and Quezon City, and spans 27 kilometers from La Mesa Water Reservoir in Purview, Quezon City, all the way to the mouth of the Manila Bay at the Centennial Park in Navotas City. This is one of the most polluted waterways in Metro Manila and one of the major tributaries of Manila Bay. Next slide, please. So first, let me explain to you what is a dredge material. So it's generally composed of a terrestrial soil or sediment, comprises also of organic minerals and other naturally occurring elements from coastal erosion that can be classified as organic or inorganic pollutants. So that is why dredge material are considered hazardous waste in other countries because of this classified pollutants. So for dredge materials in other countries, they are not allowed to dispose it into a landfill or even a reclaimed area without proper treatment. So based on literature, dredge material can be applied in many construction materials such as brick manufacture, mortar and cement production, concrete production, alternative material for building and construction materials, ceramic additives, and even in pavement enhancers. Next slide. So this is a Google map of the Tulihan-Tinajeros River. So based on this map, so we have a four sampling points. We have the Tulihan Bridge, Bridge 7, Tinajeros Bridge, and near C4 Bridge, which is Barangay Tanyong. So these are the four sampling sites that will be collecting the dredge material for our study. Next slide, please. So for the sampling collection for the Tulihan Bridge, Bridge 7, and Tinajeros Bridge, so we are lucky enough that the Department of Public Works and Highways under the Bureau of Equipment help us in collecting these samples. So as you can see in the picture, so we use a grab sampling equipment in order to get the dredge materials and then place it in a blue container. Next slide, please. Okay. So for Barangay Tanyong, or the river system near the C4 Bridge, so we We were helped by the San Miguel Corporation through their corporate social responsibility initiative of dredging the part of the Tulian-Tinejeros River. That's approximately 9 kilometers. So they use as a backhoe to get the dredge material. So while they're dredging near the C4 bridge, so we have the opportunity to get some samples. Next slide, please. So among the four sampling sites, so we considered the one in which in Barangay Tinajero, Barangay Tanyong will be our raw material to be used because of the depth of the dredge material that was being accumulated. So for the sample preparation, so from the dredge material, we approximately air dried it for 2 weeks or so 14 days. Then we manually separated some solid waste such as plastic bottles, clothes, even metals through the dredge material, and then besides reduce it, as you can see in the right side of the monitor. Next slide, please. So now, after completing the preliminary sampling preparation, so we'll now proceed with the physical and chemical analysis for the dredge material. So among of these are the heavy metal analysis, the inorganic and organic compounds such as VOC or volatile organic compounds, PCBs or the polychlorinated biphenyls, and dioxins and furans. We have the CCLP or the toxicity characteristic teaching procedure, bulk density, particle distribution, elemental analysis using XRF or the excess fluorescence, and the mineralogical composition using the XRD or the X-ray diffraction analyzer. Next slide, please. So as you can see in the heavy metal analysis for the dredge material and the leachate sample, you can see that the different heavy metals are shown in different concentrations. So you have antimony, arsenic, beryllium, cadmium, chromium, copper, cyanide, lead, mercury, nickel, selenium, silver, and zinc. So because of these values, it's above the normal range. So this is considered as hazardous waste or hazardous substance in the Tulian-Tinejeros river system. Same goes with the leachate sample. So what is the implication of this? Next slide, please. So if we compare this to other river systems, for example, with the leachate sample or the liquid sample, as compared to the Marilao-Mikawayan of Bando river system, so you can see a big accumulation of chromium, copper, lead, nickel, and zinc. So we all know that the difference in the concentration of this heavy metal depends on the quality of water. So assuming that since the river system has already these types of heavy metal, so meaning the water is already polluted as compared with the other river systems. Next slide, please. So for the dredge material, so we got the sample from Bangon River in Tacloban. It's an urban river system used by Decena et al. Study in 2018. So you can see also the high concentration of chromium, copper, cyanide, nickel, and zinc in the dredge material. So that only shows that some of our river systems are really polluted with heavy metals. Next slide, please. So for the other parameters for the dredge materials and leachate sample, so we opt to measure also these parameters such as ammonia, pH, phosphorus, sulfate, sulfide, total sulfide, the total cable nitrogen, total organic carbon, and oil and grease. So you can see there the values that is above the normal range for the wastewater effluent. Next slide, please. Okay. So luckily for volatile organic compounds, so we are below the detection limit of the analyzer, that's below 1.0 microgram per kilogram. So that is a good indicator that there's no or there's less, if there is any, that is not detected by the machine of VOC in the both for the leachate and for the dredge material. Next slide, please. Same goes with the polychlorinated biphenyls. So for both samples, So there's below the detection limit of 0.04 microgram per liter for the poor sampling size. So that also shows that a good indicator that no PCB is indicated are included in the dredge material. Next slide. For dioxins and furans, so if you can look at the red box for the total hexachlor, pentachlor, and tetrachlor. So it's also below the detection limit for dredge material and leachate sample. So this is a good indicator also, or indication that dioxins, furans, and PCBs, which are persistent organic pollutants, are maybe minimal present, or if there's any, very little presence of this POP in the leachate and dredge material. So as you all know, POPs are considered as endocrine disrupting substances. Next slide, please. So for the toxicity characteristic teaching procedure, or the TCLP, so this was conducted using the dredge material to see what will be the activity of the dredge material in a natural environment, especially on landfills, if heavy metals will leach into the environment at this condition. So as you can see, so if you look at Barangay Tanyo, which is our, um, but we also compare the other materials, we can see that there are really leaching of heavy metals for arsenic, barium, cadmium, lead, mercury, nickel, selenium, and zinc. So that only shows that uh, the dredge material is it will not be possible just to place it in a landfill without any engineered safety precautions, or just put it in a empty space without taking into consideration the effects. So we need to treat them first in order to eliminate this leaching possibility. Next slide, please. Now, so we will have the XRF analysis. So this only shows the elemental analysis in the dredge material. So we have iron and silicon oxide topping the elemental analysis. So the price of silicon dioxide give us the indicator that this could be a possible use, can be possibly used for the substitution of later on construction materials such as sand and aggregate for construction materials. So as I said earlier, so based on literature, they're already been using the dredge material at different or sediments at different types of water systems such as lakes or rivers um, to these types of applications. The next slide, please. So using XRD, this coincides with our XRF, having quartz, the geoclase, sodium, iron, magnesium silicate hydroxide, and potassium, calcium, aluminum silicate hydrate. So this only shows the different mineral composition that is present in our dredge material. So next slide, please. So we also have the particle size distribution for the Tolyahan-Tingin Heros, Bridge 7 and Barangay Tanyong. However, we'll be only using Barangay Tanyong for our future project or experiment. So you can see here the particle size distribution that is mainly of a sand particles. So at the upper right hand, so passing through. So you can see the four sampling sites that we used or we collected. So next slide, please. So in this, so we are looking for the experiment side. So we will be having cement mixture, replacing partial replacement and full replacement of sand. So that's why we have a particle size distribution for sand, 90% sand, 10% dredge material. Then we have 80% sand, 20% dredge material. So these are the particle size distribution. Next slide, please. Then we have the 70-30, 60-40, and 50-50. And then we have the pure dredge material from Barangay Tanyong. So this particle size distribution is very important in the calculation of the amount of uh, cement, water, and sand that we need to use in order to do the experiment later on. So next slide, please. So now we also calculate the bulk density, which is also needed for the calculation for the correct amount of raw materials to be used for the mortar. So dredge material, we have 1.17 and we have 1.58. And then as we go along, as we decrease the percent of sand and adding dredge material, so we can also see the decrease in the bulk density at 1.51, 1.39, 1.30, 1.20, and 1.26 gram per cubic meter. So this will be used for later calculation. So next slide, please. So what would be the outlook for the chartered dream? So actually, our project is only good for 1 year, and we already expire 9 months already. And due to the pandemic and other restrictions, so we are not really having a full capacity, but we will be completing the project by the end of June. So these are our future work. So we will be immobilizing the dredge material. So by using it as a construction material additive and partial and full replacement of sand. So also we will be determining the optimum design mix for the mortar and also the application of this optimum design mix as a pavement block. So hopefully we will be having a good result after the optimization of the parameters. So we will be using this design mix in pavement blocks. So that would be one of our end goals. And also after that, we'll also determine the physical and chemical characteristics such as compressive strength and PCLP. So we will now see if after making it as a mortar or pavement block, or we will see if heavy metals and other organic compounds will be leaching out after the immobilization technique. And then lastly, we'll be having the manual operation for the production of pavement blocks. So this will be given to the chosen community, or if there's some community that will be adopting or using the dredge material from the Tulihan Tinajeros, then they can use this manual operation for use it as a business model for their community. So with that, I would like to thank everyone for listening, and thank you so much.
Ayan, so maraming salamat po muli, no, Dr. Denvert. Thank you po.
Thank you.
For sure.
Thank you, sir.
Yes, thank you po. For sure, maraming napulot ang ating mga viewers, no, dahil nag-pile up na po yung ating questions, no. Ayan, so for sure maraming napulot yung ating mga viewers, no, nagpa-pile up na yung questions natin. So talong lang po, no? Again, huwag po tayong mahiyang magtanong, paki-iwan lang po ang inyong questions sa ating Q&A chat dito sa ating Zoom meeting, and of course, sa comment section ng ating Facebook Live. Ayan. So bago po tayo mag-proceed, no, sa ating next speaker, beloved speaker, no, magkakaroon po muna tayo ng very, very short, no, na icebreaker. Again, tapos na po, baka may nanghula pa po ng sagot kanina. Wala na po, no, wala na. So yung ating next and last icebreaker for today, no, is of course Manila Bay Trivia, no. So napakadali lamang po. Napakadali lamang po, no. So magpa-flash lang po kami ng question, and of course you have to choose the correct answer from the list of choices. So very fast lang po, no. Yeah, for the questions po about sa presentations, I think it was answered already na, no? Now we will be providing those later po, no? Later on. Ayan, so yung first question natin, when did the Battle of Manila Bay happen? Ayan, so magbubukas ako ng aking Facebook para sa ating Facebook Live. Ano kaya ang sagot ng ating mga viewers? Ayan, so you have 15 seconds. Ayan. So ano kaya ang sagot ng mga tao? Ayan, so letter C, letter B, letter A. Nagkakawal. Bawal po yung price, letter lang po. A, D, A or D. Magkalapit ba yung A or D? Magkalapit lang naman, no? So ilang buwan lang. Anyway, so ano ba ang tamang sagot? Kailan ba nangyari ang Battle of Manila Bay? May 1 po ito, 1898, no? So, ayan. So, congrats po sa mga nanalo. Ayan. Pero, ayan, since nag-tie po kayo, wala po makakakuha ng prize kasi kailangan po isa lang yung mananalo. Ayan. So next question, please. Ayan, so what is the approximate length of the Manila Bay shoreline? Okay. You have 15 seconds to answer. B, C, or A? So wala po nagsasagot ng letter D. I think it's D. Mas palaban yung ating mga Facebook people. Wala pong letter E sa mga nasa Facebook. Naglalag ba tayo sa Facebook? Nadagdagan ng additional slide? Wala pong letter E, ma'am. Okay, so ano ang right answer, guys? What is the right answer? Okay. So letter D po, sabi ko sa inyo eh. So since may mga nag-type po, no, wala pong mananalo. Okay. Ayan. So next question, please. Which is the largest basin in Manila Bay watershed? Ayan. I think Cavite. Charot. Or Pampanga. Bawal po mang-open ang sagot ng host. Okay, so pwede naman no, si Dr. Eugene magpa-provide ng prize later. Isang sakong bigas daw. Luto na, laban. I-deliver sa inyo, luto na. Okay. Yung mga netizens natin sa Facebook, ha? Bakit may letter F? Ay, mali ba tong Facebook page na napuntahan ko? Okay, so ano ang correct answer? Ano? Nag-blockings na tayo kahapon. Di ba rin? Tama. Pampanga po no, ang pinaka-large na basin sa Manila Bay watershed. Ayan. Bakit yung chat ay 99+? Sobrang active naman ng ating mga attendees. Ayan. Kami lang ang biyang sagot. Tama naman po. Tama naman. Wala naman po kaming sinabi na yung tamang sagot yung mananalo. Basta kayo lang po yung sumagot, panalo na po kayo. Ayan, so may question pa ba tayo, John, or wala na? No? Ayan, so meron pa? Ayan, so which province is not part of Manila Bay watershed? Letters, well, ang galing oh, lahat ng tao letter C, pakiramdaman, may isang A, sino kaya? At saka may isa ng D. The rest are C, okay. Okay, puro C. Ba't nire-remove natin ang Rizal? Di ba dating malaki ang Rizal? Anyway, sa ating Facebook, lahat naman sila ay B. Okay, hello daw. Hello po watching with my son. Hello po sa son nyo. Yeah, I hope it's 18+. Ayan. Alright, so ano ba ang sagot natin dito? Letter C po, very good, no? Pangasinan po ang hindi kasama sa Manila Bay watershed. Ayan. So, congratulations. Yeah, panalo po kayo. Yes po. Alright. So, si Ma'am Tonet po magpo-provide ng prize, no? Mamaya po, we will meet her. So, last question po is, which of the following rivers primarily drain towards Manila Bay? So, alin ba dyan yung river na nagde-drain sa Manila Bay, yung kanyang ending or stream network papunta sa Manila Bay directly? C, D, okay. Okay, C or D. May nakita ko nagsagot ng A. Buti 99+ na yung comment. Alright, so sa ating Facebook, letter C din po ang karamihang sagot ng mga tao. At letter A, no? Ayan. Ang sipag naman ng ating netizens. Okay, ano ba ang tamang sagot? Ayan, the correct answer po is all of the above. No? So lahat po sila ay nagde-drain towards Manila Bay. Okay, so thank you so much po sa inyong participation. Ayan, sana may natutunan kayo kahit kaunti. Ako po yung gumawa niyan, so may naiambag ako. Meron akong contribution. Ayan, so enough with the icebreaker. No? So thank you so much sa pag-prepare po ng icebreaker. Actually, team po namin yung nag-prepare. No? Ayan, so maraming salamat. No? So ayop, andyan pa po tayo dahil meron pa po tayong 2 project leaders, no, na magpe-present po. Ayan. Okay, so now to continue our session, I am now calling our beloved project leader, our ever-loving, ever-caring, ever-Belena, my thesis advisor, Dr. Maria Antonia N. Tancholing, the project leader of Project US. No? Ayan. So Dr. Maria Antonia N. Tancholing is a professor of the UP College of Engineering and is the director of the Institute of Civil Engineering since 2017. No? She is the former coordinator of the Environmental Engineering Graduate Program from 2010 to 2016. She was also the former Associate Dean for Student and Industry Linkage of the UP College of Engineering. She earned her BS in Civil Engineering and MS in Environmental Engineering degrees from the University of the Philippines, Diliman, and her PhD in Civil Engineering from Tokyo Institute of Technology. So feeling ko nag-meet sila nila Dr. Denver tsaka nila Dr. Yuchi. Her research interests include solid waste management, environmental impact assessment, water quality management, and water and sanitation. She is currently the chairperson of the Philippine Association of Tertiary Level Education Institutions in Environmental Protection and Management. She also sits as a vice chairperson of South Philippines, an NGO which assists urban poor communities plan its settlements. She is also a founding partner of IM4ManilaBay, an engineering consultancy firm. She is the vice chairperson of the Environmental and Energy Engineering Specialty Group of Philippine Institute of Civil Engineers, or PICE, and also the advisor of its Student Affair Committee. So basically, 3 pages po ang curriculum vitae ni Ma'am Tonet. Ayan. So once again, let us all welcome Dr. Maria Antonia Tanchaling. Ayan. Hi, Ma'am. Welcome po.
Hello, Ses. Magandang hapon. Wala namang echo. Magandang hapon po sa inyong lahat. Maraming salamat ang haba ng intro ni Ses. Hindi niya sinama ang napaka-importanteng bahagi, no, na si Ses ay aking advisee nung undergrad at isang masayang estudyante. At syempre, staff ng IWASTO ngayon. So, good afternoon po. Thank you for staying. Mahaba ang ating hapon ngayong araw. So we are pleased to share with you the results of our one-year progress for this project, no, called IWASTO. Ang title ng aming presentation ngayon ay From Generation to Diversion, Analysis of Solid Waste Management in Select Cities within the Manila Bay watershed. Next slide, please. Yung flow, yung daloy ng aking presentation ay mag-uumpisa sa very briefly, ano ba ang aming project, some updates, ano na ang mga nagawa, and then ano ba ang practices, solid waste management practices and assessment ng policies, and from here, no, ang aming pinopropose na template for solid waste management plan. And finally, how do we move forward? Next slide. So ang main objective po ng aming project, so isa kami dun sa 4 na projects, and sa amin yung aspeto ng basura. Alam natin na ang basura ay isa sa main pollutants ng Manila Bay, so kailangan natin itong sugpuin, no, i-address. So ang aming main objective ay to develop integrated solid waste information and technology management system considering current conditions and future scenarios. Gusto nating makita ano ba in the future, no? Ano ang parang katulad ng ginawa nila Dr. Eugene sa tubig, no, ma-simulate kung anong mangyayari. Ganun din sa basura, kung anong changes gawin natin sa upstream, anong pwedeng mangyari sa characteristics ng ating basura. Also, we aim to set up appropriate waste utilization technologies to process 2 types of waste, biodegradable and plastic wastes, in selected communities. Next slide, please. So ano na ba ang mga so far nagawa namin sa aspeto ng deployment ng technologies? Nakikipag-ugnayan kami sa mga community and gumawa kami ng screening criteria para makita talaga ang kahandaan ng aming partner communities, no? Syempre, unang-una dapat tanggap nila and willing sila na gamitin ang technology na ito, no? Hindi lang yung ilalapag sa kanila, kundi para maging successful yung deployment ng technology na ito, mahalaga ang partisipasyon ng sa local level. So ito po, so far ginagawa namin, hirap na hirap kami dahil sa pandemya, pero pinipilit namin So through virtual meetings, tas nagkaroon din kami ng face-to-face. Of course, observing protocols. Next slide, please. So nakadalaw sa mga communities, yung tiningnan ang kanilang existing facilities at ibang technologies na na-deploy na sa kanila. Next slide. Ito po yung aming mga technologies na i-deploy sa aming partner community. So may napili na kaming 3 barangay at ito ang corresponding technology na i-deploy sa kanila. Una ay portable biogas digester. By the way po, lahat na technology na ito ay dinevelop ng DOST-STII. So itong biogas digester para sa Barangay San Agustin, Malabon. And ito para sa biodegradable waste din, yung composter, yung dual drum composter, para naman sa Manila, sa Barangay 412. And then para naman sa plastic waste, electroplastic densifier, at ito ay ilalagay, i-deploy sa Barangay Tanza 1 sa Navotas. By the way, maraming salamat po sa aming partners kung nakikinig sila dito siguro sa Facebook or dito sa Zoom. We look forward po for the success of these technologies. Talaga pong naaantala lang kami ng pandemya, hindi na kami ulit makapag-field work. Pero ready na sana, no? Ready nang i-testing yung mga technologies, ready nang ilagay. Next slide, please. At sa policy support studies naman, so far ang nagagawa namin ay itong assessment ng solid waste management systems na papalawigin ko mamaya after this. And tugon dito ay yung aming nakikita na improvement sana, no? So a proposed 10-year solid waste management plan template. And meron din kaming pag-aaral na ginawa tungkol sa use and disposal ng face masks. No, ano ang maaaring una, gaano ba kadami ang gamit nito, and anong pwedeng gawin dito. Next slide, please. Meron din po kaming kasama din sa project namin ang magkaroon ng mobile app and website kung saan makikita doon ang mga lahat na datos tungkol sa solid waste management, no? Pwedeng kunin from secondary sources. Pero ito ay isang tool na magagamit ng LGUs, ng regulatory agencies, and to a certain extent ng public din, para may awareness tayo, may information tayo sa nangyayari sa kalagayan ng ating basura. And then so far, nakapag-formulate na kami ng framework, gumawa kami ng survey ng mga target users, at nagkaroon na kami ng meeting sa national government agencies, no, tungkol sa paggamit nito, and eventually kung sino ang pwedeng mag-host ng mga information system na ito. Patuloy pa naman po ito, yung prosesong ito. Next slide. So ngayon, ibabahagi ko yung description ng solid waste management system sa 6 na piling LGU sa NCR. So ito yung datos na secondary data again, no, na kinuha namin sa report din ng EMB. So in terms of the waste that is generated, yung mga available na materials recovery facility, at yung ratio ng MRF per barangay. So yan po yung nakalista dyan sa ating screen. So napansin namin, wala pong datos na kinokolekta tungkol sa collection at tungkol sa measured disposal rates. Ang dalawang datos na ito, ang dalawang information na ito ay napaka-importante kung gusto talaga nating magkaroon ng clear indicators kung ano na ba ang level ng ating solid waste management system. So, next slide, please. In terms of composition ng waste na na-generate, majority po ay kitchen waste, no? The biodegradable waste, food waste, And then kasunod ay plastic. Then, syempre biodegradable din yung yard, wood, paper. So makikita natin dito yung potential talaga for recycling. So dahil dito, no, makikita natin na ang pinakamataas na bahagi ng basura natin ay kitchen waste at plastic, kaya yun din ang technology na aming dinedeploy. So plastic, lalo na lagi nating naririnig, no, ang Pilipinas ay isa sa top contributors ng plastic sa karagatan. So, kailangan natin talaga itong ma-address. Okay, next slide please. So sa assessment naman po, looking at the solid waste management plans submitted by ito yung aming 6 na LGUs na kasama sa pag-aaral, no? So yun yung basis ng aming mga recommendation din, yung aming mga observations and conclusions. Next slide, please. So kailangan nating i-point out, no, yung mga best practices sa mga LGU na ito ay yung pagkakaroon ng mga solid waste management plans na based sa barangay. So sa local level talaga, and submission ng monthly accomplishment reports ng mga barangay, presence ng waste evaluators ng ibang barangay, presence din ng marketing for the products made from the waste utilization technologies. And kailangan din nating banggitin, no, na pag meron tayong waste utilization technology, dapat defined din yung saan ba mapupunta itong mga produkto natin. No? We don't stop with just having and setting up the technology. It's very important that we also have users and off-takers of the products of our technologies. Otherwise, it's not sustainable. No? And then, so we saw that LGUs also have agreements with garbage collectors, and then some barangays also have agreements with the junk shops and even informal waste collectors. Ito rin yung kailangan nating emphasize na kung paano ma-involve ang informal waste sector. Napakahalaga ng ginagampanan nilang role, ginagampanan nilang papel sa solid waste management system, at dapat hindi sila ma-marginalize, no, kundi mahanapan kung paano sila masali, no, sa proseso at ma-maximize yung kanilang ginagawang activities. Yung points for improvement, iba-iba ang formats and contents, and siguro in terms of regulating, mahirap i-check. Kulang din ang mga progress reports nung pag-review ng solid waste management plans. Hindi lahat ng barangay may access to a materials recovery facility, no, na napaka-basic. Dito natin ipaghihiwa-hiwalay o i-store ang ating mga recyclables. Kailangan din i-specify, minsan yung waste utilization technology are also pollutive, so dapat may ganung discussion din, no, kung paano to i-address. And then finally, may mga meeting minutes na masyadong detalyado na hindi naman kailangan, and iba-iba rin yung formats. So based dito sa aming mga tiningnan, next slide please. So na pag-isipan namin mag-propose, no, paano ba natin to ma-improve. So ito ang objectives ng proposed solid waste management plan template. Number 1, para masiguro natin na yung solid waste management plan ay reflective talaga sa kung ano ang nangyayari on the ground. Pangalawa ay ma-facilitate din, mas madali para sa LGU mag-prepare ng solid waste management plan. And then finally, para din sa checking ng regulators, mag-evaluate, ito ay nakabase sa very clear, measurable indicators. may criteria na ganon. Next slide, please. So, ito yung aming pinopropose. So, yung sa left side ay yung the current template and sa right side ay yung proposed template, no? Ang ginawa lang namin ay kung pwede itong ma-streamline, mapagsama-sama yung mga related na topics at konting dagdag na information. Next slide, please. So, ipapakita ko yung may mga changes. So, kunwari sa introduction, so dito dinidiscuss yung mga batas regarding solid waste management, and we suggest magdagdag ng ibang batas na related sa solid waste management. Kunwari, Clean Water Act, Clean Air Act, and then Toxic Substances and Hazardous Act, no? Yung RA 6969. Dahil hindi lang naman RA 9003 ang affected, no, ang relevant sa solid waste management. Next slide, please. Dito naman sa chapter 4, sa waste generation and characteristics, siguro dito yung may mga bagong datos na kailangang iitala, no? So yung sa proposal, yung generated waste, no, based from the conduct ng WACS at source, meron ding guidelines na binigay din naman ang NSWMC at ito ay susundin. And then yung diverted waste, ito ay yung mga diverted, no, literally ito yung mga hindi nakarating sa tambakan ng basura. So ito yung or hindi dinala doon ng truck. So ito yung kinompost, kinokolekta sa mga MRF, sa mga junk shop, minus the residuals. No? We also have to remember, meron din namang output ang mga MRF. So hindi ito zero output, kumbaga. It is possible na meron din siyang residuals. Yon. Next slide, please. Also, sa disposed waste din, kailangan sinukat, no? Hindi siya kinuha sa isang equation such as hindi natin i-add yung after generated waste, no, hindi natin i-add yung disposed waste, that's diversion waste, diverted waste. Kasi kung ganon, wala tayong makukuhang leakage rate. Di ba? Kasi mag-a-add up, binabalance natin. Kundi, kailangan nating sukatin. Kailangan nating isukatin ang sa iba't ibang points nung basura, like as it is generated and as it is disposed. So, pati of course yung diversion rate na nakukuha nga dun sa mga sa mga junk shops, sa mga MRFs, hindi kasama yung sinunog, no? And yung leakage rate, ito yung gusto nating idagdag. I think ito yung kailangan nating gawin. Kung gusto talaga nating makita, may improvement bang nangyayari? No? So, kailangan nating ma-quantify. Ano yung leakage rate? Meaning, ano yung napunta lang sa environment? Not necessarily sa bodies of water, but eventually, dahil tayo ay puno tayo ng tubig, no? Kahit sa lupa lang natin linagay, eventually it ends up in a body of water. But anyway, leakage rate are those that end up in the environment. Yun yung gusto nating makuha, and yun ang kailangan nating indicator to monitor the progress or how good our solid waste management system is, no? And then lahat ng datos na ito ay magandang ma-visualize sa isang waste flow diagram para makita natin kung saan tayo pwede mag-intervene, no? Pag nakikita natin in a visual way. Yan, next slide. Ito ang kinuha din namin sa NSWMC procedure of doing WACS. Ito yung paano natin aaralin ang komposisyon ng ating basura So mahalaga na klaro din sa mga gumagawa, no? Pag sinabi nating recyclable plastic, ito talaga yung may infrastructure tayo dito na pwedeng mag-recycle, no? Hindi lahat ng plastic kasi na-recycle. So dapat klaro lang sa mga ganung numero, sa mga ganung classification. Next slide, please. Ito yung mga sample equations para mag-calculate ng diversion rate at leakage rate. Yung diversion rate, kukunin natin sa kung ano ang nakakarating sa mga junk shop over the waste that is generated. No? Hindi po ito target, hindi ito target diversion rate. And from there, doon natin kukunin yung diverted waste. Ito po ay actual and measured data. So ito po yung sinasabi kong leakage rate, isang paraan para malaman ito ay yung alamin natin yung amount that is generated, the amount of waste that is generated, less the amount that is diverted, and then less the disposed waste. So kung yung butal doon, hindi natin ma-account, siya ay nag-leak. Yun ang ating leakage rate. Yun. Next slide, please. So, ito po yung isang way din ng pagpakita ng waste flow diagram. No? Ginagamit ang Sankey. Pwede naman ding mas simple, no? May iba rin na software para magpakita nito. Pero ang mahalaga, makita natin at every step of the way, anong nangyayari sa basura natin. So ito po ay isang hypothetical na gumamit kami ng hypothetical data para lang mapakita visually, no, yung dito ina-assume natin na may 10% leakage rate. So makikita natin at the end, no, kung yung total na leakage rate. So yes, less the burned waste, no? So using a waste flow diagram, so we have to emphasize na kailangan ng indicators. So ito yung pwede nating sundan. Ang objective natin, kumonte ang napupunta sa sanitary landfill, lumaki ang pumupunta sa diversion, sa MRF, sa composting facilities. At syempre, target natin mag-zero, no, leakage rates. I think right now we are crafting the National Program of Action for Marine Litter. So kailangan nating pag-isipan yon. How do we have zero leakage rates? And so again, babalikan ko yung isang napaka-importanting datos din para magawa natin ito is to know the collection efficiency, collection rates. No? Yun lang maisama natin, matala natin sa mga solid waste management plans. Madali na nating makompute. Kasi pag kinukuha natin yung mga ganong datos, then makocompute natin itong mga indicators na ito. Yan. Next slide, please. So ang leakage, kung gusto nating sugpuin saan ba ang leakage, no, pwede nating tingnan along the solid waste value chain, no. At different points pwedeng magkaroon ng leakage. Kunwari from waste generator, pwedeng intentional, no, voluntary leakage, kumbaga tinapon niya talaga sa direct dumping, kumbaga. Pwede rin involuntary, halimbawa na tumba yung basurahan or bumaha, no, yun yung mga involuntary leakage na mapupunta sa environment. And then while it's being collected, pwede rin may leakage, no, pwedeng tumulo sa truck, linipad, or hindi maayos ang pagkagawa sa truck. And then sa junk shops, pwede rin may leakage, no? Marami pong junk shops na hindi din naman well maintained, no? Sa likod ng maraming MRF, parang parang mga dump sites na rin. And then finally, sa waste disposal, kung hindi maganda ang pagka-manage ng waste disposal facilities like open dump sites, no, they are already considered leak to the environment kasi wala namang management. So part na sila ng environment. Wala tayong control na to minimize the risks of the wastes, no, from harming public health and the environment. Yan. So, yun siguro gusto nating ma-emphasize if we really want to tackle the problem of solid waste management, no? We have to look at the entire system. Saan ba ang problema? Actually, ang sunod naming gustong gawin, siguro kausapin yung infrastructure for collection ng waste, no? Ano bang problema? How do we define ano yung coverage nyo? Kasi kahit ang report ay 100% collection, bakit may nakikita pa rin tayong maraming basura sa bodies of water, no? So, yun ang gusto nating makita. Yeah. Next slide, please. Sa current solid waste management condition, halos pareho, except we have to emphasize, kailangan natin, although nandun din naman sa current template, kailangan natin pagtuunan ng pansin ang healthcare waste, lalo na sa panahon ngayon na tayo, halos lahat tayo, no, gumagamit ng face masks, at ito ay nasa bahay lang, mga kabahayan lang, at hindi katulad dati na mas madali, no, na nasa ospital ang healthcare waste. Pero ngayon, we have sa household, we have quarantine facilities na LGU ang nagmamanage ng healthcare waste. So, kailangan din ito pagtuunan ng pansin. So, dito ang ginawa rin namin, ang suggestion namin ay streamlining lang naman ng information. Dito isasama yung mga ordinances related to solid waste management. Tapos, yung key issues, binigyan namin ng separate talaga na chapter kasi ito ang nagde-define kung ano ang mga problema at ito ang mga gustong tugunan ng action plan. No? So para lang mabigyan ng highlight, kaya siya nakahiwalay. Next slide. Sa action plan naman, na-mention ko na bahagya kanina na pag yung ating kung ano man yung ating proposed activities, dapat may social and environmental impacts. No, hindi dahil ito ay isang waste utilization technology, ito ay wala ng negative impacts. No, it has positive and it can also have negative impacts. Halimbawa, yung example dito, if we have a styroplastic densifier and maaari, no, na kung hindi well ventilated, may pwedeng emissions na makaapekto sa mga tao na malapit doon. So, ano rin, kumbaga hindi solusyon ang pagkakaroon na just because we have this waste utilization technology, tapos na ang problema. No? So, dapat tinitingnan natin yung kabuuan kasi yun din ang nakaka-affect kung gagamitin ba ito ng tao o hindi. So gusto natin successful na de-deploy ang technologies, kaya lahat ng aspeto dapat tinitingnan natin. So part din ng pag-aaral namin ay gumawa ng mga life cycle assessment, no, ng mga utilization technologies na ito. Next slide, please. At sa implementation sa bahaging ito ay pareho lamang. So next slide. Sa pag-describe naman ng paano gagawin yung plano, no, sa Gantt chart, minumungkahi lang namin na yung buong 10 taon ipakita kung paano siya gagawin and pwedeng divided per quarter and maghiwa-hiwalay na lang. Pero for each implementation phase, pero maganda na makita yung kabuuan. Yan. Next slide, please. Finally, sa appendix, we suggest to include the minutes of the meetings in the appendix, no, not in the main body, and And dito rin pwedeng ilagay ang checklist ng proof of compliance sa RA 9003 and also mga proof of meetings kung kailangan, no, kung gusto ng LGU. Next slide, I think finally, gusto ko lang ibahagi din, ito po ang aming next steps. Konting-konti na lang ang oras namin. Sana we are trying our best magawa ito lahat. Sa waste utilization technologies, after deployment, kami ay mag-train ng community, ng users, and yung kasabay ng mga technical studies, how efficient are they, yun nga yung sinasabi kong mga life cycle analysis, and finally i-turn over yung equipment sa users, no, in this case sa barangay. And then sa information system, no, regarding solid waste management facilities, dinedevelop sa kasalukuyan application and website app and website development. Patuloy ang konsultasyon and later on training sa national government agencies and turnover din sa benefactor na NGAs. And pareho ito, yung technologies at yung information system, kailangan naming malatag ng maayos ang isang infrastructure, ang infrastructure na gagamit, no, for sustainability purposes. Hindi, ayaw namin na ito ay isang proyekto lamang na pagtapos na ang support ng DOST, tapos na kami, in 2 years wala nang users, then hindi rin siya sustainable, no? Parang nasa tabi-tabi lang ang aming ginawa. So ngayon pa lang inaayos namin na magkaroon ng magandang partnership at para maipatuloy ang paggamit ng mga teknolohiyang ito. Yun. And finally, sa aming policy support studies, patuloy ang pag-aaral namin ng mga polisiya. Katulad nung nasabi ko, marami kasing aspeto, no, sa basura, even just for the solid waste management plan. Like how is it reviewed, paano ba natin mapapabilis, paano yung proseso, yung mga ganung aspeto, yun nga, yung pagkolekta ng basura, marami tayong pwedeng tingnan. And so patuloy ang aming consultation, and I'd like to take the opportunity for all of the agencies who have been very patient and cooperative with giving us their feedback, no, when we call for consultation meetings, and itutuloy pa po natin ito. Yan. So ang final output, of course, we'd like to have concrete policy recommendations na para ito naman ay effective ay dapat ma-implement. So maraming salamat. That's the end po of my presentation. Thank you.
Ayan, so once again po, maraming salamat po, Ma'am Tonette, no, sa ating pong presentation, no. So enough naman, no, na again, ang project IWASTO hindi lang po science, meron ding citizen science, hindi lang basta science and technology. Marami pong aspeto na kung saan nakikibahagi, no, at nakikipag-ugnayan sa mga komunidad. Ayan. So once again, thank you so much po ulit, Ma'am Tonette. Now, to complete the updates for IM4ManilaBay program, I'm calling now our program leader and project leader, no, of Project Mapabol, Dr. Ariel C. Blanco. Ayan, so Dr. Ariel Blanco is a professor and head of the Environmental System Applications of Geomatics Engineering Research Laboratory of UP Department of Geodetic Engineering. No? So he earned his bachelor's degree in Geodetic Engineering and completed his coursework in MS Remote Sensing in UP Diliman, and completed his Master of Applied Science in Geographic Information Systems at the University of Melbourne, and his Doctor of Engineering in Environmental Informatics at the Tokyo Institute of Technology. Classmates ata silang ang ating mga project leaders. He's also currently the Deputy Executive Director of the UP National Engineering Center. Dr. Blanco has been involved in and led several research projects focusing on the applications of geospatial technology in environmental studies. These include the nationwide detailed resources assessment using LiDAR, or the Field LiDAR 2 program, the integrated assessment and modeling for blue carbon ecosystem conservation and adaptive management program, and the multi-platform and cross-sensor water quality monitoring project, plus the Geospatial Assessment and Modeling of Urban Heat Islands in the Philippines project, and now the IM4ManilaBay program and Project Mapabol. Once again, let us all welcome Dr. Ariel Blanco. Hi, sir.
Hello, Ces. So thank you very much for the introduction. So my presentation is on the monitoring Manila Bay waters from space. As mentioned, ang ating project Mapabol ay gumagamit ng mga satellite images para sa pagmamonitor ng water quality at iba pang mga parameters, kasama rin ang later yung plastics, no? Tsaka yung mga solid waste na pwedeng nandoon sa tubig or nandoon din sa lupa as open dump sites. So ito ang outline ng aming presentation. So titignan natin ang water quality trends base doon sa mga datang binahagi ng DNR EMB at saka ng Philippine Coast Guard NAPCOM. No? Titignan natin kung paano ito nagbabago. So bilang ito ay parang introduction doon sa kung paano natin ma-relate naman yung nakikita mula doon sa ating mga satellite images. So we will examine yung certain water quality parameters based on the analysis of images at kung ano ang relasyon nito doon sa nakikitang trend naman sa watershed. No? At sa panghuli, magkakaroon ng pagbabahagi ng other ongoing works and upcoming outputs ng Project Mapabol. So ito yung mga stations ng water quality sa minomonitor ng MBCO at saka ng PCG MEPCOM. So yung orange ay sa PCG at yung kulay blue-green ay sa MBCO stations. So ito ay nagko-conduct sila ng water quality survey based doon sa mga parameters na nandoon sa DAO. So nagkaroon ng trend analysis and then dinecompose yung time series data para ma-examine kung meron ba talagang trend na nakikita. No? So dito sa temperature, makita natin na yung temperature ng tubig ay increasing. No? Yung dito based dun sa data ng MBCO at PCG, MEPCOM. Sa total suspended solids, lahat ay pula, so increasing ang value ng TSS or SPM. So makita natin ano ba yung makikita ng satellite naman dito sa bahagi ng tubig na malapit sa Rojas Boulevard. So ganoon naman sa total dissolved solids, makita natin na some ay increasing, yung iba ay walang significant trend nakikita. No? So biological oxygen demand. So dito makita natin meron lang siyang 4 na points dahil yung mga stations na hindi sufficient ang data, ibig sabihin kulang-kulang or may bungi, no, ay hindi siya mahirap siyang eksakta ng klarong trend ng pagbabago. Para naman sa dissolved oxygen, you can see here that the dissolved oxygen is increasing, decreasing ang fecal coliform as reported in some news. Ang nutrients naman, so ng nitrate nitrogen, ay nagpapakita ng decreasing in most of the stations. No? Sa ibang stations naman ay sinasabi na walang gaanong pagbabago. No? O wala nakikitang significant trend. Sa phosphate phosphorus naman, sa makita natin na nag-decrease din ang base doon sa mga data ng MBCO at PCG. No? Paano naman ang nakikita natin mula sa space, mula sa kalawakan? So ito ay collection ng high resolution images na may resolution na 5 meters at pinapakita dito yung pagbabago ng water quality, especially yung turbidity and total suspended solids, lalo sa bahagi ng Pampanga River Delta, ganun din sa Pasig River. No? So ang aim talaga po ng isa sa mga objective ng Project Mapabol ay magkaroon ng sistema para ito ay magamit ang mga images at magkaroon ng datos tungkol sa mga water quality parameters kagaya ng turbidity, TSS, chlorophyll, color dissolved organic matter, at sinusubukan din po namin yung estimation ng mga surfactants katulad ng oil and grease. No? So titingnan natin ang bahagi ito ng Pampanga River. Ito naman ay mula sa Sentinel-2 images na may resolution na 10 meters. So, gaya na bahagi kanina, so may mga ito yung areas na talagang hotspot in terms of PSS or SPM at saka doon sa chlorophyll. No? So makikita natin pag malakas ang ulan, malakas ang discharge, ang tubig na lumalabas doon sa Pampanga River ay kulay brown. No? Kung titignan natin ito naman sa Pasig River at Rojas Boulevard, so may panahon din na makikitaan natin siya ng tubig na maraming sediments. No? So minsan nagkaroon kami ng fieldwork dyan, nakita namin na ang tubig din ay naging berde, no? Indicator na maraming liya o maraming phytoplankton. At syempre, naaral din namin sa Pasig River, hindi lamang yung mga ganung parameters, kundi minomonitor din yung mga lumalabas na plastics. No? So sa parte naman ng Cavite, kung saan nakita natin dito yung pagbabago din doon sa area na may pogo, no? At nagkakaroon din dito ng pagkunti ng mangroves, no? Itong area na to ay nagkakaroon din ng panahon napaka-turbid. Oh. So tinignan din namin yung sea surface temperature. Ito ay mula sa MODIS. So ito ay mula 2002 hanggang 2018. So ang resolution nito ay 4 kilometers. So ang sea surface temperature sa Manila Bay ay nag-range from around 26 degrees Celsius to 32 degrees Celsius. So makita natin dito na ang areas na malapit sa coast ay sila yung mas maiinit, no? Kumpara doon sa tubig na nasa bukana ng Manila Bay. Kung titignan natin ang datos na ito, so mula doon ito ay estimate or average for the entire bay, no? So makita natin na pwedeng ang datos na ito, taas, baba, and so on. So may cycle tayo nakikita. Ito ay pwedeng i-decompose at makita ang trend, makita ang component na seasonal, at yung remainder or yung random. No? So interested tayo na makita yung trend, no? Dito sa temperature. At dito makita natin na may gradual increase in temperature. So tinataya na sa loob ng panahong nabanggit, no? So 2002 to 2018, tumaas ang temperatura ng tubig ng mga siguro mga 0.4 degrees Celsius. No? So ang trend ay gradually increasing. So ito ay consistent doon din sa nakita doon sa temperature trend na increasing mula doon sa MEPCOM and EMB stations. No? So ito pong mga ganitong analysis, decomposition, ay siya pong ginagawa din natin doon sa turbidity at sa chlorophyll para makita ano ba talaga yung trend. No? So kung babalikan natin itong SST, so increasing trend is observed for the past 19 years and the median SST is 29.7. Ito ay pasok pa doon sa Class SB standard ng DOT 2016-08. So tignan naman natin ngayon ang mga layers, no? Total suspended matter layers na na-derive naman mula sa Sentinel-3. Ang Sentinel-3 ay kagaya ng Sentinel-2 ay libre na nakukuha at ito ay pinababayad ng European Space Agency. No? So gumagamit ang project ng model ngayon ng tinatawag na C2RCC upang makapag-estimate ng total suspended matter. So ito ay in gram per cubic meter. So ang resolution, spatial resolution ng pixel ng ating Sentinel-3 ay 300. No? So pinapakita dito yung similarity ng patterns kada buwan ng bawat taon, so mula 2017 hanggang 2020. So ito yung kailangan nating i-analyze kung meron bang nakikitang trend ng pagbabago, no? Whether ang trend ay tumataas or bumababa or walang significant trend. At kung saan ito related, no? Kung bakit nagkakaroon ng ganung pagtaas in total suspended matter. No? So kung titignan natin yung isa pang parameter na estimate ay yung chlorophyll A, no? Or ang measure ng ating primary productivity. So makikita natin dito na similar ang pattern na makikita natin. Hotspot yung areas dito sa may kung saan may discharges from Pampanga River na mataas ang na-expect na mataas ang nutrients dahil sa maraming mga agricultural lands and activities in the watershed. But of course, plus yung discharges of nutrients coming from houses. So ganun din sa bahagi ng malapit sa Pasig River at sa Obando River. So kung titingnan natin sa 2020, side by side itong TSM at chlorophyll A, no, makita natin ang spatial correlation ng dalawang parameter na ito. No? Kung saan matataas din ang TSM, typically mataas din ang chlorophyll A. No? Sapagkat itong mga sediments na ito ay usually may kasama siyang nutrients, no? Including yung phosphate na sediment absorbed. No? So makita rin natin kung saan dito may mga matataas na chlorophyll. So hindi lamang dito sa bahagi ng Pampanga River, kundi doon din sa area ng Cavite at bandang Bulacan at malapit sa Pasig River. No? Gayon din sa area dito ng Cavite River Basin. So ito po yung pwede nating magawa with the satellite images. No? So ginagamit natin to para makita kung ano yung nangyari sa past at ano yung kasulukuyang tubig, no? Kalagay ng tubig sa Manila Bay, sa Laguna Lake, ganun din sa mga ilog. No? So ito pong mga datos na pinakita na yung mga layers na derive ay pwede pong i-analyze para magkaroon ng tinatawag nating parang hotspot map, spatio-temporal hotspot and cold spot map. No? So dito ang hotspot ay sinasabi natin, ito yung napapalibutan, mataas na value ng TSM o mataas na value ng chlorophyll A at ito ay napapalibutan din ng matataas na value. No? At ang hotspot analysis na ginawa nito ni Engineer Jomer ay hindi ito yung spatial hotspot lang. Ito ay kino-consider yung temporal component. So kung titignan natin itong mapa na to, pinapakita nito sa northern part na ito na meron kang tinatawag na persistent hotspot. Ibig sabihin, palagi siyang hotspot, palagi siyang mataas ang value. No? At ang hotspot sa konteksto nito ay mga around 45 to 170 mg per liter ang value. No? So makita natin habang lumalayo tayo dito doon sa Pampanga River mouth, so nagkakaroon tayo ng sporadic hotspot. So ibig sabihin, paminsan-minsan ay meron kang hotspot. No? Pagdaloy natin, pagdako natin dito sa gitna ng bay, makita natin na walang hotspot or walang nakikitang trend, no? Doon sa TSM or total suspended matter. Pag tinignan natin yung dito sa may Pasig, no? Makita natin dito ay sporadic hotspot. So minsan mataas ang TSM, minsan hindi. Pero kapansin-pansin din na meron tayong may mga new hotspot or emerging hotspot na nakikita sa ilang bahagi ng area na ito. No? Gayon din malapit dito sa Pasig River. At kung titignan natin dito sa Cavite River Basin sa coast niya, so we can see na meron dito mga sporadic hotspot, no? Na malapit sa bayan ng Naik, ganun din sa Ternate. No? At gayon din dito sa bandang Imus. No? Cavite. So kapag ang ating watershed ay less ang vegetation cover, tapos meron kang of course ulan na mag-erode nito at magdadala ng sediments papunta sa ilog at papunta sa bay, then we expect of course na magkakaroon ka ng mataas na total suspended. No? So kailangan natin makita yun. No? So ito nga yung mga sinatawag natin iba't ibang klase ng hotspots. So persistent hotspots, so with the TSM as high as 170 mg per liter. So ito ay matatagpuan sa Guagua, Pampanga at Angat River. At meron din tayong tinatawag ng sporadic hotspot. So paminsan-minsan ay mataas at pwedeng umabot ng 110 mg per liter. So ganun doon sa area ng Obando, Bulacan, Pasig at Imus at ilang-ilang river. Kung titignan naman natin ang patterns na spatial and temporal na trends and hotspots and cold spots makikita for chlorophyll ay mas siya no, mas diverse and varied. Pakita natin dito na meron ka pa ring matataas na or persistent na hotspot. Pero meron ka ring mga cool spot, no? Especially syempre yung nasa outer sea na, no? Or buka na dito ng ng Manila Bay, na kung saan meron kang tinatawag na consecutive hotspot or persistent hotspot, and also in some cases maybe diminishing cold spot, no? So mostly cold spot ang nandito sa area na to, at sa kung saan meron kang malalaas na river discharges sa Pampanga, sa even dito sa may Bataan area at dito sa may Obando and Pasig, no, river, makikita natin ang intensifying hotspot or consecutive hotspot, persistent hotspot. Habang lumalayo, ang pattern ay nagkakaroon ng sporadic at saka oscillating, no. So dito ang tinitignan ay yung epekto ng nutrient-rich water, no, na isang requirement para magkaroon ka ng algal bloom. At kung meron kang algal bloom, so ito ay maaaring mag-result into low DO once na magkaroon ng die-off or decomposition, at maaaring magkaroon ng fish kill in certain areas na palaging nagkakaroon ng algal bloom, no. So ang mga persistent hotspots na nabanggit ay pwedeng umabot ng up to 20 micrograms per liter. So yun sa mga bahaging tinuturo na ito ng arrow. So discharges from the Pasig River, from Imus River, and ilang-ilang also. So those are areas in addition to the northwest area of the bay and coastal areas ng Bulacan, dahil sa nutrients coming from agricultural and aquacultural activities. So meron ding mga intensifying hotspots, lalo ito sa ang ibig sabihin nito, sa past 3.5 years, so meron kang nakikita na increasing trend, no. So yung hotspots ay palaki ng palaki o pataas ng pataas ang value, no. So the coastal waters of Caloocan and Navotas City are classified as intensifying hotspots. Meron ka rin sporadic hotspots, so switching between no pattern and hotspot for the past 3.5 years. And ito ay up to around 12 microgram per liter. At meron ka rin oscillating hotspot na pwedeng hotspot sa December, pero yung nakaraang buwan ay cold spot siya, no, o mas mababa siya. So yung pag ganun na taas baba or cold spot shifting to cold spot, hot spot, and so on, ay considered as the oscillating hotspot. So of course, the Bataan and Metro Manila, you have 11 to 12 microgram per liter. And then you have for the coastal waters of Naik, Ternate, Maragondon area, oscillating hotspot din, ito ay up to 13 microgram per liter. So para doon sa bahagi na yon, nakikita na yung entire coastline ng Manila Bay is a hotspot for chlorophyll A. For TSM, the northwest portion of Manila Bay, where Pampanga River and Guagua River discharge, are persistent hotspots. No? At maraming bahagi tayo na point out na merong matataas na or significantly high TSM concentration. So ngayon gusto natin tignan kung ito ba ay kung ano yung trend, no? So how does the water quality change at different parts of the bay? So yung mga pinesend kanina na animated na chlorophyll A and TSM. So far tinignan po natin yung sa TSM, no? At ito yung mga stations na tinitignan na halimbawa sa Pasig River, malapit sa Pasig River, palayo sa Pasig River. Tinignan din yung mula sa Pampanga, no? Palayo mula sa Pampanga River, no? So ano yung pattern na makikita natin? So ito po ay actually isa rin sa mga tanong na natanggap before nung unang i-launch ang IM4ManilaBay, na given or excluding yung effect ng seasonality, ano ba talaga yung trend ng water quality sa Manila Bay, no? So kung titignan natin doon sa near the mouth of Manila Bay, makita natin dito sa area na malapit sa Bataan, ang trend ay may nakita na pagbaba mula sa taon, for example, 2018, 2019. Pero sa ibang bahagi naman nakita na may pagtaas ng TSM, no? Based sa decomposition analysis, no? So kung titignan natin yung mga stations sa paligid ng Manila Bay, so defined yung increase dito sa Naik area. So pataas, of course meron kang minsan mababa, minsan mataas, no? But yung overall change ay pataas, no? So ganun din dito sa may bandang Ternate. Pag tinignan natin yung Pasig ay may pagtaas sa unang bahagi, mga 2017 at to middle of 2018, pero nagkaroon ng transition to decreasing trend in DTSM. No? So ganun din yung makita natin doon sa iba na sa Obando naman may pagtaas, no? And then yung latter part is bumababa siya. So gusto nating ma-explain ano ba yung sanhi ng mga ganito, no? So marahil sa nagbabagong pattern din and trends sa ulan, or nagbabagong trend din ng land cover, no? Especially yung mga nagkakaroon tayo ng kagaya na pinakita ni Dr. Eugene, ng pagbabago doon sa land cover, no? So yun ay yung dapat na makita vis-a-vis yung rainfall na data na para doon sa mga watersheds ng Manila Bay, no? So kung titignan natin dito sa parte naman ng Bataan, ang nagiging overall trend ay pababa. Though merong of course na panahon na mataas din ang total suspended matter, no, trend-wise. So sa Pampanga River, so ito yung station na malapit at ang lignan kung paano nababago habang lumalayo, no? So ito ay naging consistent doon sa nakita rin ng spatio-temporal hotspot using the space-time cube. So pag malapit sa Pampanga River, so you have an increasing and then decreasing pattern. No? Dito sa station 2 na to, so meron kang increasing and then may decrease. No? At habang yung mas malayo na kinukonsider nating mga oscillating and sporadic hotspot, yun ay ang overall trend doon ay pababa with some occasion na nagkakaroon ng peak, no? So tinignan din yung sa Roas Boulevard na isang bahagi kung saan critical din dahil maraming dito discharges din coming from the facilities, the structures and so on, no? From commercial and residential and other uses, no? So ito yung station 1, station 2, pababa hanggang station 6. We can see na yung trend dito ay pataas, no? At may iba is meron siyang mix, no? So mataas, minsan mababa and so on. So meron kang nakikitang ganoong cycle, no? So tinitignan din sa project na ito kung ang data ba ay merong ay homogeneous, no? Or pwede ba siyang isang mag-fit ka ng trend line doon o kailangan mong tignan na siya ay hindi homogeneous, no? Ang time series data doon sa mga points na pinakita kanina, most of them are homogeneous, no? But there is one station here dito sa itong area na to, sa Cavite 2 station na tinatawag namin. So ito ay hindi siya homogeneous, so nagkaroon ng shift, no, in the pattern. At ito ay magandang i-relate kung ano ba itong naging sanhi ng ganitong shifting in the trend. So what drives these changes? So kailangan tignan kung ano yung naging estado ng land cover, pagbabago ng land cover, tsaka yung, of course kasama doon yung bareness, no? So dito sa vegetation cover, ang tinignan ay yung data na NDVI or Normalized Difference Vegetation Index. Isa sa mga popular na vegetation index na magpapakita kung saan mataas na value, ibig sabihin mas maraming abundance, no, ng mataas ang abundance ng vegetation or vegetative cover, no? Mula din sa mga ganung images, no, na NDVI or vegetation index, we can also estimate the degree of bareness ng isang area, no? Sa pag-aaral na ito, ginawa muna na kinonsider na ang value of 0 up to 0.1 or 0.2 ay makakonsider nating bare, no? So tinignan din ang pagbabago ng rainfall. So merong tinatawag na chirps data at ito ay nagbibigay ng intensity ng rainfall kada buwan na spatially distributed sa pamamagitan ng iba't ibang layers, no? So gaya ng ginawa doon sa trend analysis sa water quality, yung mga datos na ito ay tinignan din yung trend na nakikita, no? So for the rainfall in the Manila Bay watershed, so the average is 6.98 millimeter per month, no? Precipitation peaks during July and on August as we know it. And kung titingnan natin yung trend, so ito yung after ng decomposition analysis, we can see that there's no overall strong trend na present doon sa whole data set. But what we can see are there are some portions or periods, no? So for example, like from 2003 to 2009, so yung trend in the rainfall during that period ay medyo pataas, no? So may panahon naman na ang trend ay pababa. So yung pinakita nating datos kanina ay ang coverage lang niya ay 2017 at to 2019. So ito yung titingnan basically na portion, no? At i-relate doon sa nakitang trend, no? For the case of Pasig, tinignan yung trend ng vegetative cover, bareness, and also rainfall para doon sa Pasig Marikina sub-basin. So makikita natin itong box na to, yung may pula, nung panahon na mataas ang level ng number of pixels na bare at mababa ang NDVI, no? At may considerable rainfall, around mga 8 millimeters, ay makita natin na doon yung mataas din yung TSM, no, trend sa Pasig River Station, no? At yung mga sumunod na buwan na mababa yung ulan, no, kahit na medyo mataas din yung ating areas na considered as bare at mababa ang ay nagkaroon din naman ng pagbaba noong TSM. So pag tinignan natin yung sa Bulacan River Basin, maaring dito sa trend na to na pinapakita, ito yung ulan, mas mababa dito, tapos mababa dito yung say vegetation, no? Pero of course mataas yung areas na bare, no? So kahit na may hindi ganun kalakas halimbawa yung ulan kumpara dito sa sa mga nakaraang buwan, ito ay hindi naman magreresulta talaga ng lumabang PSM, no? In fact, based dun sa trend na nakita, yung panahon na to na meron kang mataas na area na bare, tas meron kang certain level of rainfall, ay nag-result into high TSM trend value. So ganun din pag tinignan natin sa Pampanga River, no? So dito tinignan nyo mula around say May 2017 up to June 2020. So makikita natin na yung peak halimbawa na ito ng TSM for Pampanga Station 1 ay tumutugma dito sa panahon ng November 2018 kung saan mababa ang vegetative cover, mataas ang bare areas at may considerable amount of rainfall, no? So yung pattern na nakita natin sa decrease ng TSM trend ay sumasabay din doon sa pagbaba nitong bare line na to or pagtaas naman ng NDVI. So ganun din ang makikita natin doon sa Bataan, no? So in fact, so based dito sa nakikita natin, so pwede nating ma-estimate ang magiging TSM value at the mouth of the rivers, no, or areas na malapit sa river mouth base doon sa condition ng sub-watersheds, no, sub-basins. So ganun din ang nakita doon sa Cavite River, no, river basin, no. Tinignan yung sa Labak sub-watershed at saka yung sa Maragondon. So ito ay mga land cover maps na mula sa global data, no. So ito ay ang resolution nito is I think around mga 500 meters. So tinitingnan na nagbabago-bago ang ating ang cover nito, ang data na to is from 2001 or 2 up to 2019, no? 2011 to 2019. So pag tinignan natin yung kada basin, no? So in this case, ito yung Pampanga River Basin. So dito ay may kaunting pagtaas ng forest coverage. Pero ito ay masusuri pa natin sa pamamagitan ng iba pang datos. Yung Bataan River Basin ay nakita natin na bumababa ang grassland, no? At meron kang increase in the shrubland. Pagdating naman doon sa agriculture at saka sa forest, so ito yung nakikitang pagbabago mula 2011 hanggang 2019, no? So yung Bulacan River Basin na relatively ay maliit. So makita natin na pababa yung nakitang pagbabago ng shrubland at pataas yung sa urban area, no? Pababa din doon sa grassland, no? Para sa Cavite River Basin, pababa ang sa shrubland at meron kang nakikitang slight increase in the forested area, but ito ay maliit na bahagi lamang, no? At itong areas na orange, yung ating agricultural area, ay may kaunting pagbabago din, no? For the Pasig Marikina and Laguna de Bay, so we can see that there are dips in terms of forest cover during this period, and the shrubland is increasing, and then after 2014, so nagkaroon ng decrease na. So ito po ay babalikan din dahil itong mga data na to ay base doon sa images na mas mababa yung resolution. Pero ang proyekto po ay gumagawa din ng land cover mapping utilizing Sentinel-2 para magkaroon ng detalyeng land use land cover na pwedeng ibahagi sa mga LGU, no? So kung titignan natin doon sa Manila, Pampanga River, for example, so merong mataas na net loss, no? O ito ay yung gain sa grassland, ito ay yung loss naman sa grassland. Makita natin na mas marami yung naging losses compared sa naging gain, no? Pagdating naman sa Bataan, so mas marami kang losses sa grassland and agricultural lands, no? At itong matrix na to, ito yung ipapakita kung paano nagbago from 2011 to 2019 sa case ng Bataan. So kung titignan natin yung grassland, so some of the grassland ay naging shrubland or naging agricultural land areas, no? Ang mga ganito pong statistics or matrix and graphs ay ginawa rin sa iba't ibang bahagi tulad nitong Bulacan River Basin na mataas ang naging pagbabago doon sa agriculture and so on, no? So kung titignan natin kung paano ito yung gains and losses over the period of 2011 to 2019, we can see that maraming losses of forest cover in this area doon sa Laguna Lake Basin, no? O watershed. And then pagdating dito sa shrubland, so marami ring mga losses kumpara sa gains, no? At ganun din pagdating sa grasslands, no? So ito ay sinusuri para matignan kung ano yung relasyon doon sa trends na nakita sa TSM in particular, no? So based doon sa ating mga pinakita, so yung remote sensing ay magbibigay ng information para sa estado noong water quality, ganun din sa state ng watershed, no? So yung chlorophyll A maps, TSM hotspot maps, so ilan lang po yun sa mga layers na pinoproduce ng mappable. At ito ay patuloy na gagawin sa iba't ibang type or resolution ng images, no? So ito ay monitoring tool para makita natin kung meron nga bang nagkakaroon ng positibong pagbabago doon sa mga parameters na ito, resulta halimbawa ng ginagawa sa watershed or greening program, minimization of say soil erosion and then nutrient export. So bukod doon, ito muna yung mga ginagawa rin ng Project Mappable. So yung nakita nating mga mapa ay usually ay pwede nating makuha ng kada may isa o may gitna araw. Pero within a day, we can also have what we call yung near real-time water quality monitoring, especially kung may mga issue on blooms. No? So ito ay mula sa Himawari 8 satellite images. Ito ay from Japan, yung meteorological satellite na to, geostationary. At makita natin yung pagbabago ng chlorophyll at TSM kada 10 minutes. No? So bukod dito, tinitignan din, ini-extend din yung capability o yung mga parameters na maaring ma-derive. No? So karaniwang ginagamit ang radar images para magmapa ng large oil spill. No? Pero sa normal na panahon, usually mayroon ka talaga makikita mga surfactants. So maaaring ito ay oil and grease or pwede rin biological secretions na makikita natin doon sa tubig. No? So ito yung initial na yung kulay blue dito ay mga areas na merong posibleng surfactants. No? So ito ay kailangan pa namin i-verify based din doon sa mga gagawing mga field surveys. At sa bandang huli, so pinopromote po namin ang paggamit ng must-done mobile app in support of the citizen science. So ito po ay na-launch more than a month ago at may pwede nyo itong ma-download from the Google Play Store. No? So magkakaroon kami ng programa upang i-promote at maging mas marami pa ang gumamit ng ganitong sistema. So magkakaroon din ito ng must-done monitoring interface para magamit ng mga authorities sa pag-review ng mga reports na sinubmit ng publiko through the must-done mobile app. So in June or July, we will be launching the Mapabol web portal. So dito ngayon makikita o mada-download yung mga pinakita nating mga produkto na kada dating actually ng mga satellite images ay pinaprocess yun ng proyekto at para makita kung saan nagkakaroon ng mataas na pagbabago sa TSM, sa chlorophyll at iba pang parameters. No? So dito po nagtatapos ang aming presentation. Maraming salamat po.
Ayan. So maraming salamat po no. Sir Ariel, no? So, thank you so much po sa lahat ng ating mga project leaders po sa inyong mga presentations. Very informative po at maraming salamat po sa lahat ng updates, no? So ayan po ang Facebook page ng Project Mapabol, no? So you can follow their Facebook page, no, and add future questions if may isip pa po kayo, no? Now for the interest of time, punta na po agad tayo sa ating question and answer portion, ano? So meron na po tayong nalikom na tanong na mula sa ating mga audience sa ating Zoom at sa Facebook po, no? Okay, so pwede po bang turn on ng video at ng audio ng ating mga project leaders? Ayan. Hello po. Ayan. So ito po yung first question. Ito po ay address sa lahat po ng ating project leaders or kung sino po yung maaaring sumagot. Mula po kay Ma'am Adele Mapulan ng DNR. So in your efforts to clean up and rehabilitate Manila Bay, what are the tangible effects that the project achieved for Manila Bay? No? So ulitin ko po yung tanong. In your efforts to clean up and rehabilitate Manila Bay, what are the tangible effects the project achieved for Manila Bay? Ayan. So meron po bang maaaring sumagot?
Sige, ako na mauna. So thank you for that wonderful question. For the tangible results, so like for the charter dream, so we are using waste material, which is the dredge material, and converting it into a useful product, such as the concrete materials. No? So I think that is one of the tangible things that our project will be able to do, other than we will be also making manual operation on how to make this brick if ever the results will be okay. Thank you.
Okay, thank you so much po. No? So other project leaders po, baka meron po tayong dagdag na answer po for that.
Maybe I'll follow na doon. So for Project Smart, I think I can say that the project has been able to develop models, no? As I've shown in the presentation. These are tangible outputs that can be used already, for us to have better understanding, ng water environment, not only Manila Bay, but also Pasig River, Laguna de Bay, and the watershed the entire integrated system. So with such a model, we can now understand more deeply yung sabi nga ng title namin sa presentation, the where, the when, and the how. No? So these are crucial information that should guide us in selecting or identifying solution interventions for the rehabilitation of Manila Bay. Thank you.
Okay, thank you po. So, thank you, Sir Eugene. Meron pa po ba from ano? Okay, or okay na po tayo? Okay, so thank you po sa inyong sagot. No? Thank you rin po sa question. Now po, from Mr. Brando Angeles no, sa ating Facebook, yung question po ay address kay Dr. Eugene. No? So yung question po is, how can the hydrologic modeling you are using contribute to the mitigation of potential climate risk and or natural hazards? So yung question po again, how can the hydrologic modeling you are using contribute to the mitigation of potential climate risk and or natural hazards?
Okay, thank you for that interesting question. But yeah, so with the model that is representing the hydrology of the watershed of Manila Bay, we can now simulate the different conditions. As we all know, when we say climate change, we don't have a good hold of the data now to describe our hydro and meteo. So now we can hypothetically run scenarios and see the corresponding effect dun sa ating water resources. No? So for example, in the event that droughts happen, where a certain percentage of the precipitation will not be available, how much decrease would this result to the discharges of the rivers? Take note that the discharges from the rivers, as we all know, we rely so much for different water resource use. So yung mga ganong simulations, I think will be quite crucial in or for us to manage yung ating action towards adapting to a climate change or changing environment.
Okay,
So I hope I was able to answer.
Thank you so much po, Doc Eugene. So, Sir Brando, I hope na-answer po yung sagot niya. So, next question naman po again from Facebook po kay Sir Brando Angeles again. Address po ito kay Dr. Danbert, no, sir? Would you confirm that the contaminated dredge material will not affect health of people when used as substitute as construction material? So again po, would you confirm that contaminated dredge materials will not affect health of people when used as substitute for construction material?
Okay, so when they use the construction dredge material as construction material, whenever there will we will be making sure that they will be using PPEs while handling this waste material to protect themselves, and also if it will be converted into a construction material, then we will also test that if the contaminant will leach out from the construction material through the environment. So we will be making sure that the health and the environment will be taken care of while handling this hazardous waste.
Okay. So thank you so much po, Sir Danbert. No? So Sir Brando, sana nasagot po ang tanong. No? Okay, next naman po kay Dr. Tadsuling. No? Hi, ma'am. So yung question po, Ma'am Tonet, ay mula po kay Miss Joanna May, no? Nurse of DPS Manila. No? So yung question niya po is, can you also consider the amount of waste that can be avoided through waste avoidance efforts per capita in the computation of leakage rate? Since we are comparing it with estimated waste generation using per capita as per WACS. So again po yung question, can you also consider the amount of waste that can be avoided through waste avoidance effort per capita in the computation of leakage rate? Since we are comparing it with estimated waste generation using per capita as per WACS.
Thank you, Seth. Thank you, Ma'am Joanna, for your question. Hindi po ako sigurado kung nakuha ko talaga, pero I think ang important din, I think gusto nyong makita rin ang efforts regarding waste minimization, waste reduction, tama ba? So pwede natin siyang makita sa pag may regular waste generation data tayo through WACS, then makikita natin yung pagbaba. So kasi yung din ang gusto nating mangyari na bumaba talaga per capita ang usage, ang pag-produce ng basura. And ito ay produkto ng maraming activities starting from less consumption and up to waste minimization effort ng bahay. So aside from WAC, siguro pwede nating dagdagan ng mga interview or survey. Yes, it's important data, pero hindi siya related sa leakage. No? Although siyempre may indirect, na kung napakadami mong generation tapos hindi naman bumababa, then siyempre lalaki din yung leakage rates. If that's what you want to ask about. Thank you.
Okay po. Thank you so much, Ma'am Jeanette. Maraming salamat po. At thank you rin po sa question, Ma'am Joanna. Ayan, so yung next question po natin ay address po kay Dr. Blanco, no, from Mr. Reynan Phil-Suyom, no? So ito po yung question, sir. Medyo mahaba po. One of the possible ways to address the continued pollution of Manila Bay is to identify point sources of pollution, who is producing what, and then provide appropriate technology to help them clean their wastewaters. Are there any efforts within the IM4ManilaBay project to identify the point sources? Can we gain access to these findings so we can have studies, technology development, dedicated or aligned especially to help the stakeholders address them? So, ulitin ko po ulit.
Yes, okay na.
Okay,
So dun sa Project Mappable, we are utilizing geospatial technology and citizen science. No? So very important na ma-recognize na from satellite images, we can see if there are effluents, if there are discharges. No? But this depends on maybe the timing as well as the resolution of the images that we are utilizing. No? But in terms of pollution, hindi lang naman siya doon sa liquid waste, no? But we also are developing methods in order to map, for example, accumulation of solid waste in the waterways as well as in the overland. No? And in tandem, so we would like to promote the citizen science to the must-done application, given that there are limitations from satellite remote sensing, so might as well utilize as well the participation and the power and of our citizens in reporting issues of concern. No? So that way, through the application, they can report those type of say discharges, be able to identify it, and then this will be coordinated with the DNR and LGUs to ensure that there will be proper action. No? So in the case of that, once we have seen maraming gumagamit halimbawa ng mobile application, we can see that there will be also opportunity for us to validate reports. No? If more people are reporting the same thing or close to the same area, so that's one way of characterizing the reliability of the reports, in addition to verifying it utilizing images that we have access to.
Okay, so thank you so much po, no, Sir Blanco, no, sa inyo pong answer. At thank you rin po sa question. No? Now, ito pong next question, kinumpal na lang po namin kasi parang para-parehas na ganito yung tanong. No? And I think it is addressed to Dr. Eugene. Sir, andyan po ba kayo? Ready na po ba kayo sa next question? Sir, ito na yung question natin. No? So, based on the results of the dynamic modeling, no, would water movement of Manila Bay affect the artificial dolomite beach? If so, what will be the impact on the artificial dolomite beach based on your opinion? Ayan, so yung question po ay from Mr. Brando Angeles, sir.
Okay, yeah, thank you for that question. So, as presented already, we were able to capture the dynamics of the water movement in the bay, and it seemed like, of course, the water movement is described by incoming water from offshore, and then it goes inside the shoreline. So we can expect that particles that are present there naturally will tend to be settled there as is. But for materials that are not natural, unless provided by structural intervention or protection, then they can remain in place. So what I'm saying is for now, we were not able to simulate yet because we need some more information about the properties of the dolomite and also the properties of the morphology of Manila Bay. But current patterns and circulation patterns of Manila Bay were described well, and it seemed like it will always tend to move materials in and out of the bay. So it's just a matter of time, and probably, depending on the protection measures that will be provided or the re-nourishment measure that will be conducted, and then it will tend to remain in place. But what I can only say is that for any material inside the bay, if it's not natural, then the bay will have its natural mechanism of flushing it out of the bay, unless, again, structural measures are in place to protect it from moving out. Thank you.
Ayan. So thank you so much, Doc Eugene. Sobrang linaw, no? Actually, nakuha kayo sa... Thank you, sir. Maraming salamat, no? Thank you din po sa question. Very, very informative question and answer, no? Okay, next question po, no? So, konti na lang po yung mababasa natin at wala na ho tayong oras. So, yung question po is mula sa FB Live from Miss Marites Pangalinan, no? Address po kay Dr. Tansuling, kay Ma'am Tonet. Good day, ma'am. Applicable po ba ang iwasto sa LGU? Maaari po ba naming balikan ang mga presentation sa FB page nyo para ma-review namin ulit? Tamang-tama po, nag-update po kami ng SWM plan. Thank you.
Opo, yung present ko po na proposed solid waste management plan ay syempre para sa mga LGU yon, and matutuwa po kami kung ito ay makakatulong sa inyo at hihintayin din namin ang inyong feedback. Please get in touch with us kung kailangan nyo po ng assistance. Nandito po ang team, lalo na po si Ses. Yan, tandaan nyo. Opo, we'll be happy to collaborate also with you. And we really need your feedback po sa aming mga recommendations. Thank you.
Okay, thank you po, Ma'am Tonet. Thank you rin po sa question. And last, we have, I think, last two questions, no? So, address po kay Dr. Blanco. So, sir, yung question po ay from Miss Emelita Lingat, no, sa ating Zoom. Sir, do you have plan to include the Marilao, Maykawayan o Bandor River system in the characterization of river sediments, no? If included, when it would be po?
Sa ano ba yan? Sa Mapabol?
Okay. Dr. Dr. Blanco daw.
Ayan. Baka ang tinutukoy doon is, for example, pinakita doon sa presentation na tinitignan yung differences, no, yung CSM. So yun po ay gagawin din sa mga river na nakita naman sa images, no. So halimbawa sa Pasig River, meron na kaming na-develop na initial model dyan para ma-estimate din yung turbidity and chlorophyll and other parameters, no. So yun ay balak ting gawin sa iba't ibang major river systems na draining to Manila Bay, no. So titingnan din po namin 'yon sa pamamagitan ng mga images na meron kami, at bukod doon ay nagde-develop din ang Mapabol ng turbidity sensor, ng low cost turbidity sensor na pwedeng ibahagi din sa mga partner LGUs o SUCs, no, upang ma-monitor din yung say turbidity and chlorophyll doon sa mga areas of interest, no. So nagkaroon din po ng survey diyan sa mga sa Marilao, Maykawayan River plus other rivers sa Hagonoy. So titingnan niyo yung water quality at ito ay kino-correlate din natin doon sa mga images, no. So gagawin po yun ng titingnan din, imbestigahan ng Project Mapabol yung pagbabago ng tubig doon sa mga lugar na yan. Thank you.
Okay, so thank you so much po, Dr. Ariel. Now, so meron po tayong last question from Mr. Jason Pinzano sa ating Zoom. So to anyone po sa ating mga project leaders, aside from microplastic, pharmaceuticals, and endocrine disruptors, what other emerging pollutants will be monitored? Like PFAS? So yun po yung question. So ang question po is, aside from microplastics, pharmaceuticals, and endocrine disruptors, what other emerging pollutants will be monitored? No? So ayan po.
For the dredge material and leachate, we already are done with the characterization. And unfortunately, yun lang yung mga pollutants na aming monitor, which is heavy metal, PCB, versus endurance, and yung VOC, and also the other inorganic parameters. Maybe in the next project could also be included.
Okay, thank you, sir. Any more po pa sa ating project leaders?
Originally, ang Project Mappable ay mayroon pang mga kasama dapat na projects, no? So for example, I think yung project ni Dr. Wendell Rivera ay nagsimula na. Tinitingnan naman yung mga pathogens, mga Giardia and other pathogens, no, na maaring magkaroon magbigay ng risk para mga tao na halimbawa lumalangoy or gumagamit ng tubig ng nasa Manila Bay. So yung EDCs ay dapat maging proyekto ni Dr. Piches from the College of Science, no. So yun ay I think inaayos ang pagpopondo noon. So kamakailan nagkaroon ng discussion ang proyekto ni Dr. Rivera, so nagkaroon ng common stations para yung monitor na parameters ay hindi siya madoble, no. Pero yon ang tinitingnan nila is mga pathogens naman.
Okay po, thank you, sir. So, any more po sa ating project leaders? Ayan, so kung wala na po, thank you so much po sa ating project leaders, no. Maraming salamat po sa pagpe-present ng mga updates, no. And higit sa lahat sa pagsasagot po sa ating mga katanungan ng audience natin, no. So, sorry po, wala na po tayong time, no. Kaya pasensya na po. I hope nasagot po ang karamihan ng ating mga tanong. If you have further questions po, you can message yung IM4ManilaBay program FB page and the FB pages ng ating mga projects. Ipa-flash po yan or itatype po later ng ating mga session moderators, no? So ayan, so thank you so much po project leaders. Thank you rin po sa lahat ng mga nagtanong, no? And we will promise to answer all of your questions, no, in the future po. Ayan, so to formally close the event, no, tinatawagan ko po ang ating beloved Executive Director ng DOST-Philippine Council for Industry, Energy and Emerging Technology Research and Development or DOST-PCIEERD, Dr. Enrico C. Paringit. Ayan, so Dr. Enrico Paringit is the Executive Director of the Philippine Council for Industry, Energy and Emerging Technology Research, no, or ang ating DOST-PCIEERD. So before being sworn in as the agency's Executive Director in December 2018, Dr. Paringit has also shared his expertise in the Department of Geodetic Engineering, College of Engineering, UP Diliman as a research fellow, research affiliate, teaching faculty, department chair, and professorial chair. Once again, let us all welcome Dr. Enrico Paringit, no? Hi, sir. Andiyan na po ba? Hello po. Magandang hapon.
Thank you very much, Ses. Naabutan ko yung mga huling mga katanungan, no? And somebody popped the 379 million peso question. Sa mga nakatunghay nung ating forum ngayong hapon na ito, na-satisfy yung inyong katanungan. But I think if you look at what our researchers had done, napakarami na po, no, in 1 year's time na inimplement na po nila itong project na ito. Napakarami po ng kanila na-accomplish, no. This despite the limitations brought about by the pandemic. Di po sila masyado partida pa po yun. Di pa sila nakapag fieldwork ng malaki. Hindi pa po sila nakapagbiyahe. Sila po ay nagkaroon pa ng mga problema sa restrictions, no. Hindi po yun dahilan, no, para hindi nila magawa yung mga kinumit nila na gagawin. And truly, we appreciate the effort of our researchers in coming up with this forum. Kasi isa po yun sa hiling namin sa kanila, sa pamumuno, of course, ni Dr. Blanco, and of course, ni Dr. Chanchulin, nakita ko dyan, si Eugene, no, na magawa itong na maisagawa nila itong forum na to. Kasi gusto rin naming maipaliwanag sa publiko, sa ating mga namumuno sa mga local government, sa ating partners sa DNR, at of course sa publiko, kung ano-ano mga pag-aaral at mga kaalaman na ang nakikita natin sa mga pag-aaral na nakukuha sa Manila Bay, no? I'm sure it's in fact a well-studied Bay area, but it always pays if you have a fresh take, no, using new technologies, new approaches, new methods, no? And I think through these fresh lenses, we will get a lot of insights, understanding, and which can serve as a basis for planning and decision making. Sige, bago ako magpatuloy, ang aking isang pakay dito ay of course, may pagbigay alam din sa lahat what our plans are. Of course, nabanggit ko na, I'd like to recognize, of course, the program stalwarts, no? Dr. Blanco, Dr. Herrera, the new project leader of Charted Dream, no? Dr. Denvert, Ma'am Tonet, of course, Miss Alea Arca of DILG, our representatives from the Pasig City, and Sec Boy sends his regards. He really sees the high potential of this project to make a contribution in our concerted efforts, no? Our whole of government efforts towards the cleanup of Manila Bay. We'd also like to, of course, thank our participants from NEDA, DNR, of course, no, our very staunch partner, DILG, local government units sa programang ito. Nagpapasalamat po ang PCIEERD at nabigyan po kami ng panahon para mag-impart ng konti naming direksyon, no? Saan namin gustong dalhin ang larangan ng environmental research, environmental technology research. Manila Bay has been such a huge effort, and we'd like to thank the team for organizing this wonderful conference. We also thank you for organizing and then inviting also the key stakeholders to this conference. Gusto ko lang po ipakita ano ba ang papel ng DOST at ng PCIEERD, no, dito sa effort na ito, no. Ang DOST PCIEERD po ay isang ahensya na tumutulong para magsagawa ng research, no. So in other words, kami po ay nagpopondo para maisagawa itong mga pag-aaral na ito, no, pagsasaliksik. Kung makikita nyo po, over the years, we have been really staunchly supporting a lot of research related to the environment, for the assessment of the environment, for the technologies that will enable us also to clean up, no, the environment caused by pollution, caused by degradation, caused by a lot of forces, no, that try to degrade its condition. Kung makikita nyo nga po, high sa aming agenda kasi kita nyo naman, pang-5, no, if we combine both the resources of DOST PCIEERD and DOST itself, no, in supporting a lot of these programs. So it really affirms the commitment, no, our commitment to providing solutions for the challenges that we are facing in the field of environment, may it be in air, land, or in the case of Manila Bay water, no? Although some of its problems are rooted actually on land, no. In fact, if we look at our portfolio of projects, makikita nyo po ang laki, ang dami naming projects sa environment. At ito po ay backed up, no, by core technologies that support it. Nandiyan po yung, syempre nandiyan yung bumabandera dito yung paggamit ng mga satellite imagery para meron tayong panaka-naka, no, na view or snapshot ng kung may basura ba, hindi malinaw ba yung tubig, malabo ba yung tubig, no? And what we're saying now is that there are a lot of prospects in bringing all of these technologies to fruition, no? In being able to come up with good information so that this information could be used for actual planning, preparation, and decision making in anything and everything that we do. The interventions that we introduce in cleaning up Manila Bay, of course, and its tributaries. So sana po magamit, no, itong mga technologies na ito. I'm sure marami pang nasa arsenal natin ng mga technologies ay hindi pa na-i-apply sa coastal areas, coastal and environmental areas kagaya ng Manila Bay, no. So we look forward to actually making all of this applicable, no, or applied, no. So kung interesado po kayo, wag po kayong maghihiyang magtanong pagka gusto niyo malaman ano pa ba yung mga technologies available for us to be able to take care of solid waste, wastewater, assessment, no, assessment, mapping, etc. So pwede po nating pakinabangan yung mga ininvesta na natin na technology. Moving forward po, we really set out to follow, no, the roadmap for the water environment. So sumusunod lang po kami kung ano ang sinasabi ng ating mga mananaliksik, ng ating mga siyentipiko, kung ano dapat ang paglaanan natin ng oras, ng panahon, ng resources, no, investments in technology kasi magastos naman po talaga ang paglilinis ng environment. Pero maliban dun po sa paglilinis, kailan din pag-ukulan din natin ng pansin kung gaano ka-epektibo yung ginagawa natin at kung hindi pa natin ginagawa, ano po ang kasalukuyang condition at kung kailangan na itong linisin. Kagaya nga po ng Manila Bay. So this is our S&T roadmap for the water sector in terms of water quality and water security. So under water quality, we envision, of course, to support projects that are geared towards ecological functioning services of water ecosystems. We also supported projects under the water security and sufficiency that work also towards the upgrading of quality water ecosystems in the country. So sana tunghayan po ninyo ito o di kayo po makiisa po tayo if you belong to any research and development institution, government agency, or higher educational institution, please join us and participate in the process of providing more knowledge, understanding, and solutions to the challenges that we face in this sector. Maganda po rin, nabanggit po kanina ni Dr. Blanco na mahalaga ang partisipasyon, ang pakikiisa ng mga mamamayan para masiguradong manatiling malinis ang ating kapaligiran. Kaya we commend really the effort towards the creation of Masdan app, which is created to inform government on the developments in taking place in Manila Bay and how else we can make our response better. So what we're calling for greater engagement because we believe that we can serve the people more if we make these kinds of technologies more accessible to the public. So you can use this app to report anything that you see in Manila Bay, both good and bad actually. Well, I'm also going to take this opportunity. We are calling on our researchers, our innovators, our scientists, our engineers, of course, to submit your proposals in the next round. Ayan. From May 3 to June 3, we will be opening our information proposal submission portal, the DPMIS, for and I think we have calls in the environmental sector. I think for air meron, and we call all eligible entities from the private and public universities, colleges, research and development institutions, members of the consortia, our R&D consortia, even non-profit laboratories, even public or private non-profit S&T institutions located in the Philippines to respond to this call. Yan. So, for more details on what the calls are, ano ba yung mga hinahanap namin sa kasalukuyan, kasi hindi naman po lahat ng research talaga pwede naming pondohan, every year, pinipili po namin, of course, in cooperation and in coordination, of course, with the researchers, with the pool of researchers that we already have, kung ano yung nararapat nating gawin sa mga susunod pang mga araw, So, the complete package of call and call application forms can be viewed in our website and should be submitted to DPMIS. So, kami po sa DOST-PCIEERD, gusto po namin, kami po yung inyong nangungunang partner sa pagpapaunlad ng ating research and development because we want to continue this effort in coming up with innovative and creative and responsive solutions to the pressing problems in our environment. All in the name of making sure that we have a concerted effort, both us at the government, our partners like, of course, UP, ITDI, and we call on, of course, our industry partners to partner with us as we bring about or come up with more innovative undertakings. So kung meron po kayong idea, let us continue our good conversation. Kahit po yung ating mga partners pala sa local government, meron po kaming call para sa smart cities, di ba? So, pwede po kayong mag-participate doon. Let us know if you're interested. Let's talk more about your research needs by connecting us through our different social media platforms. Maraming salamat po ulit. Maraming salamat sa organizers ng conference na ito, Dr. Blanco, Dr. Tanchuling, pwede na kayong Dr. Eugene, Dr. Denbert, pwede na kayong sabitan ng medalya sa inyong gallant effort in making sure that we we understand more about what's happening in the Bay towards us, no? Yung sa iba-ibang branches, no, of government, of course, in our local government units, as they respond, no, to this call to clean up the Bay and make sure that it remains pristine for all the next generations to enjoy. Mabuhay po tayong lahat and magandang hapon.
Ayan, so maraming salamat po ulit, Sir Paringit. No? So thank you so much po sa inyong time at of course inyong continuous effort to support science and technology. No? So yung DPMIS po ay very helpful niyan. So ako po personally nakapag-apply sa RIE-ETOL. Very accommodating po ang picture. No? So yeah, tuloy po tayo. Apply po tayo. Na sobrang ganda pong platform. Ayan, so maraming salamat po. I think pwede natin yan. So kulang na po ang oras natin kanina pero marami pa po tayong mga tanong na hindi nasagot, no? Personally ako nakulangan din ako sa time, no? So ayan, so tayo po kung meron tayong karagdagang tanong, suggestions, comment, ayan po ang Facebook naka-post naman po, no? Ang Facebook link ng ating whole program at ng mga projects under IM4ManilaBay program. Ayan, so ayan. Alright, paka-message na lamang po sila, no? At sa tanong po about presentations, yes, we will be sending the copy of presentations to your email. So ayun po, maraming salamat po muli sa ating lahat, sa lahat ng ating guest speakers, sa lahat ng ating project leaders, no? Kay Dr. Paligid, thank you po, sa lahat ng project staff at sa mga punong abala, and of course, ng ating attendees, our key stakeholders from different government agencies, academe and non-government organizations. Thank you so much po na nakita ko nag-uusap tayo sa chat, no? So napakagandang simula, no, na nakakapagkaroon ng communication sa lahat ng mga involved organizations na to rehabilitate Manila Bay. Ayan, so once again, thank you so much po. I hope we all support the initiative of all organizations and agencies to rehabilitate the Manila Bay, no? So it has been a lovely webinar. Ingat po tayong lahat, no? Always observe social distancing, follow the health protocols, at magpabakuna po tayo kung may pagkakataon na, no? Pagpupugay din po sa ating mga health workers. Sa mga nasa Zoom po, maaari po ba tayong magstay ng ilang minutes? Meron lang po tayong photo op and quick reminders, no? So ayun po. Ayan, so once again, this has been